Hey, everybody. My name is Brian Collins. I'm the Chief Strategy Officer at AngelHack, and I'm super excited to be presenting to you guys the call for code application, what you guys need to do to be successful in your application, a little bit about the video pitch. Basically, I just want to answer all the questions you might have about how you actually submit. It's been a huge program. We've had tens of thousands of people apply. I've been involved from the beginning, and it's been really cool seeing you guys come through the Slack, come through all the different pieces. Just a quick heads up at the beginning. If you have not joined the Slack group, make sure you do. If you need that link, once again, you can reach out to us at AngelHack, info@angelhack.com, and we'll get you that Slack link. So what we're going to do today is we're going to go through the application form. I want to make sure that everybody's on the same page as to what they are actually going to be submitting and how that submission works. And then I'm going to give you a couple of tips on what to do for one portion specifically, which is the video pitch, that 3-minute video pitch. So what we're going to do first is this screen that you see here is exactly what you're going to see when you go to submit your submission on the Unoodle link. If you still don't have the Unoodle link, again, shoot us an email, info@angelhack.com. We can get that to you. But moreover, we can also make sure that you guys get the Slack channel, which is where it is pinned. So that'll be the last time I talk about that. This is what the application form is going to look like. And I want to go through piece by piece what all these different pieces are, how important they are, well, really what we're looking for before we go through the different pieces. First up, your team name. You got to have a team name. Please don't make it your name. That just makes it confusing for us and the judges as we're going through the different pieces. So we do need a specific team name, your project name, for example, of what it is that you guys have actually built. So whatever you're calling that group, that's what we want to know. We'll need your teammate names and emails. Now, it's important to note that these first two pieces, specifically the names and emails, those are only being shared with us, the AngelHack team. We'll be contacting you if we need more information, if we have questions from the judges, and as well, if you win. This is how we contact you. But the judges don't get this information. So the only people who are getting this are your friendly AngelHack organizers. Now let's get into the actual real application. First, we need a high-level pitch. This is your quick 7-word, and it's only 7, high-level rundown of what your project is. This helps the judges. Reminder that we've had tens of thousands of people apply. We have hundreds of applications that have already been started, and we're expecting quite a few more. So this is a great way to grab the attention of your judge. So keep in mind, especially those first few rounds of judging, these judges are going to see a ton of different applications. So the easiest way to ensure that you're doing the right thing here is to grab their attention with a really interesting, really cool 7-word high-level pitch. And I think this is something that a lot of people push to the side, but it's a really important thing to fully kind of grab that attention here. Then we're giving you the full describe your solution in more detail. You have 500 words to do this. This is your really dig into and help us understand exactly what the program is. Now, I am going to flag something. Some people, and we're going to talk more about the video pitch later, some people just put the script of what they want to say in the video pitch as they're describing your solution. So they're the exact same thing. I would not suggest doing that. I think you're wasting the ability to being able to offer a lot more in-depth pieces. What I would think about for the in-depth description of the solution, and what I've seen to be most successful, is when you really start to think about what are the pieces that, when you're doing the video, a lot of the video should focus on the demo. We'll talk more about that later. But other pieces for this description should really be around things maybe you don't see in the demo, maybe you don't see in a quick run through. So I would actually suggest that you build out your video demo first and come back to this section. And I think once we go through the video demo, it'll be a little bit more self-explanatory as we go through this. Solution roadmap. One of the big portions of this program is that the judges really want to know, especially the final judges, really want to know that you're going to be continuing to work on your solution well after the virtual hackathon is over. Once the challenge is finished, we want to know that you guys are really working on this after the fact. So as a portion of that, we want to see some type of a solution roadmap. Where are you? What have you accomplished? And where are you going from here? Now, that roadmap can be in a variety of different formats. It can be a variety of different pieces, but just something to keep in mind that it's really important to do. And depending on the type of application, the type of program, the type of product that you've built out, it can be in a variety of different formats. In a perfect world, everybody would submit this as a PDF. That makes it easiest for the judges if everything was in one file format. But if you're building a mobile application, it's pretty easy to put things as a JPEG and make it into a PDF. If you're building something more blockchain oriented, for example, it might be harder to showcase this in a visual format. But as much as you can, we want you to think about the solution roadmap as a visual format for showing people where you were, where you are, and where you want to go with the product. Next up, we need the link to your code repo. Now, this portion is very important because it covers two pieces. One is one of the first rounds of judging, where the judges are going to go through and check your code to ensure that you have at least one working IBM service, an IBM cloud service. I'll talk more about that in a second. And then the other piece is if you're actually selected to win, our teams will go through and they'll actually take a very close look at your code to ensure that there's no foul play. This is what the code repo is for. But one of the biggest mistakes that people make is sometimes we get a private code repo. It may not be hosted on GitHub, but it's hosted on some other repo server or a private server. That's fine if you want to keep your repo private. I fully understand. But you need to give us access. So if you're creating a private repo, we need to have access. And if that means giving us your ID and password, that's one way of doing it. If you can make it just password protected, we need to have the password, and it needs to be in this section. So typically the best way to do this is you have the link, you do a couple of spaces, and then you write out the actual password right here in this section. So that's another really important piece to know. It's really important for us to have this. And that takes us to the video pitch. Now, we're going to talk more about the video pitch later, but same rules apply with the code repo. If you're going to make your video pitch private, whether it's a YouTube link or a Vimeo link, and it needs a password, that's fine. But make sure that you take the password and you drop it again in here. So drop the link, hit the space bar a couple of times, and drop the password in as well. And just make sure you note in both of these sections that this is the password. So password, : here's what it is. It's one of the biggest mistakes we get, because if I have to reach out to you, if our team has to reach out to you, it's going to slow down the judges. And depending on your turnaround time, you may be disqualified because we don't hear back from you in time. We have a very tight amount of time to judge all these. We only have about a week. So it's a really tight period. And because it's a global hackathon, everybody's in different time zones. So do yourself a favor, follow the instructions, make sure you include the password if you're going to make these private. The last piece that's really important is what IBM cloud services did you use? Remember, again, you have to include at least one cloud service. So if you're going to include one, make sure that you list it out here, because when the judges go through, the technical judges go through that first round of judging, where they're really just looking to see, was an IBM service actually utilized and is it deployed in the repo? What they're going to do is they're going to look at the cloud services that you've listed, that are listed here, and then they're going to go to your repo and make sure that they're listed out. So if you're listing something here, it needs to be listed in your repo. It needs to be shown as working. That is the first step of the judging process before the judges come back and look at all the different judging criteria. And if you don't meet that, you won't even make it to the second round. So that's it. Let's kind of go through this again from the top. But we need your team name. That's your guys' fun team name. We need the teammates' names and emails. Again, these two sections are really for the organizers, myself and our team here, to ensure that we can reach out to you guys if we need anything. High-level pitch. I mentioned this before, but I think this is one of the most important pieces to differentiate your team, especially after judges will have seen hundreds and hundreds of submissions. How do you make yourself different? How do you capture their attention? And how do you briefly explain what it is you built this out? Describe your solution in more detail. I mentioned it earlier. I'm going to reference it one more time. I would build your video pitch first. We're going to talk about the video pitch in just a second. And then describe your solution in more detail so that you can supplement what's already in your video. Then we're going to do the solution roadmap. Again, we really want to see, where were you? What have you accomplished so far? Where do you want to go? Depending on what you're building, this can be in different formats. You'll be allowed to include basically any file format that you want to build. But if possible, try and make it a PDF. It's easiest for us judges to go through all this. The link to the repo, if you're going to make it a private repo, we need to know what the password is. Again, the video pitch as well. If you need to make it a private video pitch, make sure that the password is there. Finally, what IBM cloud services did you use? Make sure you list out all the ones that you used. But most importantly, make sure you're not listing out something that didn't actually get listed in your repo, because the tech team will be testing that. And that's it. It's a fairly straightforward application, but from a timing perspective, it's going to take you a few hours. And especially the video pitch is going to take you probably a few days to nail. And let's talk about the video pitch for a moment, because there's some really important things that I want to present to you guys and to talk to you about what is going to make you the most successful when doing this. So we're going to talk about 7 different steps towards success for a video pitch, a virtual video pitch. How do you differentiate yourself? And I cannot overstate enough the importance of the video pitch. Most judges, myself included, the first thing we look at is the video pitch. And we base most of our scores off of that. The most important piece of the video pitch is going to be the demo. We're going to talk about that later. I'm going to walk you guys through how to actually format all of this, how to work on timings for all this, all these different pieces. So let's get started. First and foremost, I'm going to walk you through the easiest rule, but it's the most important rule. This is a really amazing virtual hackathon program. It's Call for Code. It's focused on solving and fighting disaster relief efforts around the world through a variety of different things. You've decided to give up some time to work on this program. You've decided to take a step back and really focus on why you want to give back in some way through what you're building out. You need to showcase that passion in your video pitch. So no matter what you're doing and no matter what you're writing out, make sure that that passion really comes through. Because if we as the judges can't seem to see you being passionate about it, we can't get passionate about it. That does not mean that you need to go through and, have balloon drops happening and confetti and all that stuff, or just kind of, woohoo, like screaming and yelling at the camera. That's not passion. That's just excitement. Not talking about exciting stuff. We're talking about being passionate and really showcasing that passion all the way through. So we start that as rule number 1, because if you can really dig deep and think about that, then it's going to be the most effective way for you to really ensure that your entire pitch is really, really strong. Number 2, you need to think about your pitch early. Now, the good news is, if you're listening to this, you probably have already accomplished this, but I mentioned it earlier. I've found when building out video pitches, both for myself, but also in working with other teams from many of the other virtual hacks that AngelHack and IBM run, that the longer that you can start building out your pitch, the better. The best teams that I've seen from virtual hackathons tend to work on their video pitch for about 3 to 4 days before getting that final recording. The earlier you can start thinking about the pitch, the more you can start putting into it, the better. Rule number 3, this is called the 3 golden points. So this is how you can actually build out the most effective video pitch. What I mean by that is you only have 3 minutes to pitch. How in the world can you fully and successfully present your ideas in only 3 minutes? Well, it works like this. Generally speaking, we suggest taking 45 seconds to work on your problem and solution statements. What exactly are you trying to solve, and how have you solved it? And that needs to be the first thing in your video pitch. What exactly are you trying to solve, and how have you solved it? A minute and a half on the demo. This is the most important thing. We want to see what you built. We want to see it in real time. We want to really be walked through everything that you guys have built and what it is. A minute and a half on the demo, a full user flow if you can do it, a real use case if you can walk us through. We really want to see that whole thing. So again, about a minute and a half. Finally, 45 seconds on next steps. Where are you going from here? What do you want to build out? 45 seconds on problem solution, a minute and a half on the demo, 45 seconds on next steps. And if you think about it and you think of the submission form that we just went over, you'll realize that the video pitch is really covering multiple different portions, at least as a starter period, of the different portions of the submission itself. The problem and solution, that's one portion of the full description, the 500-word description that we talked about earlier. The demo, that's just the real version of the code repo, the actual user flow and all of that. And then the next steps, that's your roadmap. So really what you're doing with the video pitch is you're focusing in on each of the different pieces of the submission and giving us a teaser of what we're going to find with the rest of your submission. Rule number 4, the importance of next steps. So I mentioned those 45 seconds, but I cannot, as I mentioned earlier, I cannot overstate it enough. The judges, and especially those final judges, are really going to be looking to see what projects are actually looking to be built out beyond just this program, beyond just this hackathon. Next steps are the number one areas judges have questions, and you really want to spend your time doing your research and making sure you understand. The most common questions that judges have about next steps that you're going to want to see if you can cover during your video pitch, and definitely mentioning during your description or even your roadmap, is how is this project different from other projects in the market? In other words, competitive analysis. What makes this business model different? How will it make money? If it won't make money, how is it going to be a sustainable concept in the future? Essentially, the next steps is idea validation. It's understanding and proving that this fits in the market, that it's viable, and that it's valuable, as well as it's scalable and it has impact. So those are the things that we really want you to think about with the next steps. And that's why, even though we mentioned it in that earlier slide, it's so important to have an entire slide dedicated on the importance of next steps. Rule number 5, do 2 things at once. You've got full control of your video demo. It is totally okay for you to be showing one thing on the screen and talking about something else. A really good example of this is really take a look at your user flow. Spend time going through your entire demo over and over and over again until you nail it as much as you can. I did a video demo a few months ago where I spent probably 2 days just going through the user flow over and over and over, answering any questions that I had to ensure that when I actually recorded it, I knew what, when I show it, does not need explanation and what does. Because if I'm going through a login screen, for example, that might be a great time for me to talk through something else. That might be a great time for me to talk through a different portion of the program, a different portion of what it is that we're actually working on. Everybody's seen a login screen. Another option that I see a lot in demos is something involving maps, for example. Something that, putting in and searching for a map or showcasing, let's say you were doing a disaster relief piece where you were showcasing on a map all the different SOS calls that you'd receive, just as one example. If you were doing that, the map is fairly self-explanatory. So the key is, what else can you explain? What isn't self-explanatory? Is this a time to talk about your backend? Is this a time to talk about your business model? Is this a time to talk about the things that they won't see from the demo? Rule number 5, the best demos do 2 things at once. Rule number 6, anticipate questions. And that reminds me, I probably should have led with this, but if anybody has any questions, drop them in the chat. I'll switch over to them at the end of this as well. So feel free to just start dropping them there. And I'm going to do a little Q&A at the end, just in case anybody has any questions. And we're just about there. Number 6 out of 7, so nearly done. Anticipate questions. What we mean by this is, once you have the first draft of your demo, you want to share it with people. You want to share it with the people on your team, obviously, but you also want to share it with people who maybe only slightly know what you're working on or don't know it at all. You want to know what questions that they ask when you put it together, because you're going to want to update your demo again after you hear those questions to make sure you're answering it. Or, and this goes back to what we were talking about with the form, answering those questions in the description itself. So the point is, you do one version of the demo, you pass it around to people, you get their feedback, you build out another version of the demo based on their feedback, answering as many of those questions as you can. And if you absolutely can't answer certain questions, you may want to think about making your description less as a full description and more as some type of an FAQ. If you're getting lots of questions about the product, that could be a really easy way to fill out that section as well. So a couple of things to keep in mind, but anticipating questions is incredibly important, because remember, you're not really going to get a chance to answer any questions from the judges. They need to have all of the information at their fingertips in order to really effectively ensure that they're presenting and creating the best projects. And finally, rule number 7, practice. Practice, 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 practice. This is going to take time. There's a bunch of prizes on the line. There's some really cool stuff. And this is a really important program. This is real, viable, valuable stuff that we're working on. So you're going to want to put time into this. I mentioned it before. I'll say it again. 3 to 4 days is the average time I know that some of our top virtual hackathon teams have done this in the past. So I just want to highlight that. You're going to want to practice. So let's go through those again from the top to the bottom. Number 7 is practice, practice. You're going to want to make sure that you put the time in and the effort in. Anticipate those questions, because you will not have a chance to really answer questions from the judges themselves. So you want to make sure that you're giving it out to people who might have good questions for you, and then taking those same pieces and incorporating them into your demo or adding them into the description. Rule number 5, doing 2 things at once. This is you spending time looking at your demo, really focusing in and ensuring that you know your demo so well, you know what you need to talk about to explain and what is self-explanatory, what else you can fill in during that minute and a half that you go over your demos. Next steps are incredibly important. Cannot overstate them enough for the 3rd time today. And the reason they're so important is this number 1 area is that judges have questions. So you want to make sure that you're taking your time, you're doing your research, and that you understand where you fit in the market, how are you viable, how are you valuable, how are you impactful, how are you scalable. Number 3 golden points, 45 seconds on problem and solution, a minute and a half on the demo, and 45 seconds on next steps. Thinking about your pitch early, because you know that it's going to take you much more than just a couple of hours or a quick afternoon recording to make this effective. And finally, number 1, remember why you got started on this program at all, to be passionate, to make sure that you're focusing on the real reason that you wanted to focus on this, the exciting thing that you're actually building out. And with that, guys, I'm going to switch over on my side. You shouldn't see it, but if anybody has any questions, start dropping them into the chat. Everybody who's joined. Otherwise, I'll start answering as I go. I do got one question. Great. Is it good to showcase earlier work in the domain in the video for about a minute? So I think, Samha, thanks for the question. Do me a favor and let me know if this doesn't fully answer it. But essentially, if you're asking, should you be showcasing earlier work towards this product? So for example, early stages of this work. I wouldn't include that in the actual video demo. I would include that in the roadmap. I would really showcase how in the roadmap this has come along. Here's what version 1 looked like, or here's what version 0.1 looked like, this is what 0.2 looked like, et cetera, et cetera. I would not include it in the video demo and that portion of the pitch, because that most effective way that you can build something out there is you really want to show what you finally built on. Use the roadmap section to show the different iterations and the different levels. And I think that's going to be the most effective way for you to do that. So hopefully that answered your question. If it didn't, let me know. Just drop it in the chat as well. I'll wait a second to see if there's any other questions that pop into the chat. Is there a recommended format or resolution for the video? Any recommended tools? Daniel, good question. There's no recommended format or resolution, although the one thing I'll say is if somehow you're able to be recording at a very high resolution, maybe don't shoot in 4K or anything along those lines. We just don't know what all the judges' devices are going to be at, and some of them might not be able to handle that. Again, I would highly suggest just using a YouTube or Vimeo link for this, whatever you're most comfortable with as far as the actual distribution. On the tools that you guys might want to use, what I find to be most effective is kind of a mix between, you are going to want to edit this, I think is probably really important to say as well. So this is not going to be something that you're just going to do a 3-minute pitch with one screen share that you're then just going to record and speak through the whole thing. You're going to want to do a screen share recording, for example, for your demo and really walk through that. Another really helpful tip, get a basic get a basic microphone that you can plug into your computer so you can have a slightly better sound quality. Quick, easy tip that really ups your production level. Do that as a screen share that you can then record. If you're on Mac, it's actually built in to your QuickTime player. If you have a PC, I think there's also an option there as well. And there's a ton of free tools online that you can use, which is really simple. But the flip side of that is when it comes to, that's for the screen sharing side. When it comes to your going to the outside of the demo, so the problem solution or the next steps, it really depends on what you want to showcase. If you want to just, for next steps, showcase your roadmap, you'll kind of walk through your roadmap, that's fine. Maybe a screen sharing piece works well there. If you really want to do more of an interview style process with your teams, which I've seen before as well, make sure that you're looking up at least, basic lighting instruments and basic video recording pieces, and never have more than one person speaking to camera at a time. There's a really good tip for you guys. But my best practice would be to definitely do a screen share recording straight from your computer with a decent microphone for the demo, and then be editing in the other two pieces as you guys see appropriate. So I'm going to leave it to you guys. If you know your projects best, you know how to best showcase the problem and solution, how to best showcase the next steps. So I really want you to think about that. We got another question here: is roadmap an architecture map with each technical updates? It can be. It absolutely can be. That's a good way to walk through it. Again, it's hard to, I don't want to make a single defining answer because it's so dependent upon the product that you're building out. If the product that you're really building is a very simple tool, for example, that ties into a larger business sense, then the roadmap there may be much more built out on a business side, on a business model side, for example, and where you guys plan to go, your customer acquisition plan, pieces like that. If what you're building is a much more technical product and really a product base, then utilizing a roadmap as an architecture map is good too. But I'm going to argue the best way to do this is actually to combine both. Being able to showcase a technical roadmap and a business plan roadmap. And again, a lot of you are, I know this from people I've talked to in the Slack and some early submissions I've seen coming through Unoodle. A lot of you are focusing on more charity works or possibly making these into charities or nonprofits. That's fine. But just make sure that you're showcasing how are you going to get this into the market? How do you get this into the hands of the people that you need to use it? It doesn't need to be revenue generating. It just needs to showcase how you're going to get it into users' hands. So, Tom, to your second question on the roadmap, it can absolutely be a roadmap as an architecture map, but my best practice would be to include it as both an architecture map inclusion, so a technical side, the technical roadmap, as well as some type of business roadmap. How are you going to grow and scale from there? I'm going to give it one more second to see if there's any questions. I'm not seeing anything popping up on the chat. So with that, folks, I want to thank everybody for coming on. Really appreciate it. Again, if you guys have any questions at all, anything that pops up, info@angelhack.com, or if you're in the Slack, drop the question in the Slack and we'll go from there. I want to thank everybody for joining. I want to thank IBM again for helping to sponsor and support this amazing program. We're super excited about it. And folks, we're coming up to the last really week, a little bit more, but really week before we officially close this out. So thanks everybody. Good luck. And once again, if you have any questions, let us know.
Hi, everyone. My name is Vennam, and I'm a developer advocate with IBM. Today, I want to talk to you about Loopback, which is a Node.js API framework, as it clearly says over here. But the cool thing is it's completely open source. It was originally developed by a company called StrongLoop. And after acquiring StrongLoop, IBM and StrongLoop kind of worked together to build out our API portfolio, kind of all of the solutions that we have in the space, from anywhere from creating APIs, managing them, securing them, and then even socializing them. So you might be wondering, like, what exactly an API management solution could be used for? Why are we focusing on APIs, that kind of thing? I think a good place to start would just be, let's jump into the code, let's create some APIs, and then we'll kind of get into some of the more nitty-gritty topics where we can really dig into the reason why you'd want to use a API framework or a management solution. And when I say API management, a lot of you might be familiar with that. Maybe you've heard of the term API gateway, essentially the same thing. But let's go ahead and get started with Loopback. Just to kind of give you an idea, let's go to the GitHub page for Loopback. And we'll see that it's a fairly popular open source project, about 122 contributors, written entirely in Node.js. And you can see here that quite a few stars. I think this project has been growing for quite some time. As a quick overview, it allows you to design extensible APIs using Node.js underlying. The great thing about that is, Node.js is very performant, great for I/O, great for throughput. So the fact is, once you actually start creating some APIs, it's generating Node code underneath. You can jump in there, edit it, play with the Node.js, even write custom functions, descriptors, and that kind of thing. But I feel like I'm talking too much about the actual software itself, and I think everyone here would likely rather see it in action. So let's go ahead and get started. To install Loopback, you just want to run this npm command. And if you've used Node.js before, or even just developed front-end applications, you might be familiar with npm, which is the Node.js package manager. So let's go ahead and jump in and actually start creating a Loopback application. So jumping to my terminal here, I'll start with the command lb, stands for Loopback. And what that's going to do is allow me to actually generate an application. You know what? Before I run this command, let's actually create a directory to hold this application. So let's say I want to make an application that keeps tracks of cars, so different kinds of cars. So maybe I'm an enthusiast and I collect cars. Maybe I'm like just need a application to manage to keep track of all the inventory of cars that I might have at the time, something like that. So I'll jump in here. I'll run the lb command. It's going to give me a few options to get started with. So what's the name of your application? What version of Loopback? Let's go ahead and start with an empty server, right? So no APIs already configured for me. I do have the option of starting with like a default user auth or like a simple API, but since I want to build from scratch, it's an empty server. And what it's going to go ahead and do for me now is actually generate that application. What we see here is a Yeoman generator. So a Yeoman generator, essentially what it does is allows me to generate application code completely from scratch. So let's go ahead and get started here. The first thing I want to do is actually create a data source connection so that when I actually put something, when I actually call these APIs to store whatever it might be, I want it to be connected to a real database. So let me go ahead and load that up. Give me just 1 second. And I'm going to switch over context here to IBM Cloud. So I've actually got it pulled up already. So let me just jump there. And we're going to go into the catalog. And we'll find a database that we can start working with. So I just need to scroll down to the databases section and click this. And I usually like to get started with Cloudin, because Cloudin is very easy to start with. There's a light version basically meaning a totally free version. It's really weird that the 2 random letters it chose was SI. My name is Sai. It's not spelled like that, but no, I feel like it's a sign. I'm just going to call it Cloudin-Sai. Choose legacy and IAM credentials and free. I have a feeling that this might complain because I already have a Cloudin instance created. Let's hope that it doesn't. OK, it didn't. Awesome. So it's created a brand new Cloudin instance for me. And I'm going to go ahead and hit Launch Cloudin Dashboard, because right off the bat, even though I have a database as a service, Cloudin, I need to actually create the individual database that's going to hold my cars. So I'm going to create a database called cars. Hit create. And that's it. So I've got my car created, or my database called cars created. And I want to actually be able to access it in my application. So I need to find the credentials to actually access this database, right? So jumping back to the IBM Cloud view where I generated the Cloudin and launched the dashboard, go to the Service Credentials tab and create a new set of credentials for my application. So we'll call it whatever, Service Credentials 1. Don't really need to worry about creating too many of these parameters. I'll go ahead and just click Add. and it'll give me a set of credentials to actually access this application. And yes, this is all public for you guys to see, but I will probably clean it up right after this talk. And let's see, let's go ahead and get started by doing lb data source. And we'll set the data source name as cloudintsci. And here we see that it gives me a number of options for connecting to different types of databases. What's really cool here is that although StrongLoop has developed a number of connectors for connecting to various databases in the cloud, there's also a number of connectors out there that the community has created. So let's take a look at some of the Loopback community connectors that were created. And you can see there's a small list of them here, but if we want to look at all of the ones that are out there, it's actually a massive list. I think someone out there actually made a full list of them. Try and see if I can find it quickly. Okay. I can't find it off the top of my head, but there's connectors out there for pretty much every type of database out there, anything you can think of. For example, if I wanted to do Loopback connector, CouchDB as an example, there's going to be a GitHub page where someone has created a CouchDB connector. And then there's going to be different flavors of that as well, because different people have different types of connectors they might want to use. But yeah, it's really cool that the community has gotten so involved and enables support for all of these different connections. So we'll go ahead and click the IBM Cloud and DB one. And we'll take the connection string URL that was right here. Give me 1 second to find the URL. Okay, here we go. There we go. Pasted it in. Then the name of the database is cars, right? We'll do that. I don't need to put in username and password because that's actually also already part of the connection URL. And I do want to install the connector because I want to test this application out locally before we get to the next steps. So right now it's going to install that connector from GitHub, from NPM for that database. So what have we done so far? We've generated a Loopback application and we've created a data source connection. Just to kind of prove that those things exist, I'm going to launch VS Code from this directory. Don't need this guy here. And maybe make this a little bit bigger. So we see a standard Node.js application. We'll look at server, look at data sources. We can see that our Cloudint data source has been created and it's ready for a model to actually add things into that database. So next thing we do, we create a model. So the cool thing about Loopback is that it's model-driven API creation. So you don't actually have to go in, like for example, if you were to be using Express, you would have to jump in and essentially, you would have to essentially go in and create all of the different API endpoints, the puts, the gets, the posts, for all of the CRUD operations. When in reality, a lot of times when you're working with APIs, you know the type of artifact you want to store, right? It's usually some type of JSON object. And you want those APIs to just be there. You don't want to have to go through and create all of those express entries for all of the endpoints that you want. So the model name is going to be car, because we want to store cars in here. Ask me, do I want to attach it to a data source? Yes. OK, we have already created it, so we'll attach it to the cloud and data source. Persisted model is fine. And we'll go ahead and now set up some parameters for this car. So exposed by a REST API, ignore that, common model, and let's start adding real properties. So every car is going to have a make, which is a string, it's required, no default value. A model, a string, required, no default value, a VIN number, which I believe is a combination of numbers and letters. So we'll call that a string. And this required, no default. And finally, the year, which is a number, is required, no default value. And we'll hit enter one more time because we're done creating properties. So we've created the model and we've created the data source. And I've been saying over and over that Loopback makes it really easy to create APIs, it's really straightforward, blah, 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 right? So let's actually prove it. Let's start this Node.js application. You just do node dot. It's going to find the start script and kick off my application. It says my application is listening. Let's go ahead and hit it. Okay, so it's started. It's been up for 7 seconds, 8 seconds, 9 seconds. Okay, so we know it's a real app. Let's go to the Explorer endpoint. So this is a kind of Swagger-based, open API specification-based Explorer, which is based entirely on a open API spec. But what's cool is, if everything worked properly, this application is now connected to that cloud and data source, and all of these APIs have been created for us to actually start doing CRUD against that database. So let's get started. Let's get all the cars in the database, just to make sure the database connection works. 200 response code, empty response body. Okay, that's what I expected. I mean, there's nothing in the database quite yet. So let's create a car and post it into there. So I have a Lexus RC350. I'm not going to put my real VIN in here, but I'll make up something. 2015, and I'll hit post. Seemed to work. It says it responded with what it put in, including the ID, as expected. And then let's try one more car, maybe. Let's say we put in a Toyota Camry. Change up that VIN number a little bit. Make this a 2017. And hit try it out. Okay, sweet. So it looks like everything is working properly. Just for the sake of trying this out, let's see what happens if we include some kind of like illegal values, right? So let's put letters in the number and see what happens. Try it out, syntax error. So okay, we know that it's validating that the correct type of input is coming in. So it didn't allow me to put in incorrect values for the type of object. Good stuff. We'll go to get cars and to make sure that everything is in the data source. Hit try it out, and there we go. So 2 cars that we've added to the database. So just like that, in a matter of minutes, I was able to spin up a Loopback application, a Node.js application that's fully CRUD capable, and it's actually connected up to a real database in the cloud. And just to prove it, it's a 0 number of docs. Let's refresh the page. It's going to say 3, I believe, because there's going to be, so it's going to be 2 for the cars and 1 for the design doc. So this one is the Lexus, and then this is the actual Toyota Camry. And then this is the design doc that gets automatically created by the connector. So there we go. We have a working Loopback application. It's running locally, and it's managing all my CRUD requests and APIs. Although this is great for playing with the data source, I mean, the real next step here is to get this on the cloud, right? Like it's not doing any use to anyone just running on my local machine. Maybe it's good for local development, sure, but once we really want to go to production, we want to push it to the cloud. And for this, I want to take advantage of the Cloud Foundry way of deploying applications on Bluemix, which is a great way to simply get started with a small application, just to test things out. It's great for kind of development environments. I'd really recommend moving to something like Kubernetes when you really want to move to production. But for now, just to make it quick and easy on us, we're going to just deploy that application to the cloud and using Cloud Foundry, which is a very app-centric way of doing things. We don't get a lot of control over infrastructure or hardware, but it's going to host the application for us and give us a neat URL to actually access it. And that syntax error is from that the incorrect entry we pasted, by the way. So that's expected. So we'll go ahead and clear out here. And what we want to do is push this application to the cloud, right? So to do that, the first thing I need to do is actually log in. So I'll do bx login. It's going to log me into the IBM cloud. And since I have an IBM account, I actually have to use single sign-on to log in. Most people will have to just use bx login, put their email password in. But for me, I have to do the federated login. OK, easy enough. I'm actually part of a lot of people's accounts, but I want my own. So I'll hit number 4. I don't want to update. We'll do that later. And we'll do bx target -cf because I'm managing a Cloud Foundry application. It's going to do this interactively, so it's going to give me a few pop-ups on the type of org that I want to connect to in the space. So I'm going to pick dev. Okay, I'm in my dev space. I've got my application locally. I just want to push this to the cloud, right? Seems simple enough. Let's just see it. Let's just see it in action. I'll just do bxcf push. All I'm running, and something went wrong. Let's see. Oh, requires an app name. That would be useful. So again, bxcf push. And we'll call this Loopback cars sci. I have to give it a unique name just because if someone else took that name already, then it won't give me a URL that I like. So just like that, right now what it's going to do, it's going to bundle up my local application, push it to the cloud, give me a route, Loopback cars sci.mybloomix.net. And in a few minutes here, I'm going to have this application running in the cloud and responding to API requests to store things inside my database. And honestly, I suggest as a viewer, if you want to, once this application gets started, you can actually go to this URL and start playing with the Explorer. So just go to the URL/Explorer. And you can add things to the database anyway. And be nice, let it in there. But okay, it's uploading the files, waiting for API to complete processing files. So, you know, it takes about a few minutes because it's got to upload everything and start the actual application. So we'll give it some time. In the meantime, kind of explore what a running application's UI looks like. You've exceeded the organization's memory limit. Okay, maybe something I should have checked ahead of time. So let's go ahead into my organization and delete some of the applications so that I have more space. Yeah, so I was messing with Alexa earlier, so I'll go ahead and delete that guy. Don't need it. It's taking 101 gig of my memory, actually. I'll delete this one as well. I'm actually glad you guys get to see this because this is kind of the UI that ops people, developers will have to mess with when working with the cloud. So I'll go ahead and delete the routes with it as well because I don't want to hog any routes that I'm not using. So it's deleting those two things. They were in the dev space. So effectively, I've cleared up 2 gigs of RAM. So now when I try it again, it should be OK with it. And the other thing, I'm almost positive that it's going to take advantage of the cache. So this time around, the push isn't going to take quite as long. There we go. So a few things to note here. It's going to give me 1 gig of local disk space, as well as 1 gig of RAM. There's a few other things it tells me, like what stack it's on. It's not really that important for us to note. But the important thing to keep in mind here is just that it's pushing up the code, giving us a route, and it's going to let us know how the push process goes along. So let me quickly talk about what happens when you actually push code to when the code gets output, there's a few things that it has to do, right? So one thing it'll do is actually, oh yeah, right. So I'm guessing that the upload was interfering with my connection. Thanks for calling that out, Mike. Anyway, I was saying, so while once the application code is pushed up, the cloud is going to do a few things. It's going to actually download the dependencies for my application in a fresh manner. So it's going to go to npm and download the latest and greatest set of modules to ensure that my application is using the best set of modules. And also that what that ensures is that it's going to run the same every time you push it. So it's not going to have any unexpected behavior. It lets us know that we're running a few environment variables which change how the actual application is installed. So taking a look at, we have production set to true, the environment set to production, which kind of kicks in some of the modules to behave as if you're running in production. So it's going to print out fewer warnings, fewer debug messages, that kind of thing. It downloads a version of Node.js that's compatible with what I've described in the package JSON. and installs all the dependencies from NPM, a lot faster than I can install them because it has a much better connection on the server side. Checks for a few optional features that we haven't enabled, things that allow us to do debugging in the cloud itself. And then it's going to actually start the application. Build succeeded, and now we're almost there. We just need to give it a few minutes to actually start the app. In the meantime, let's take a quick look at the dashboard, and we'll kind of run through the kind of things that you see in the IBM Cloud Dash. So there's obviously a lot of different ways you can filter between different areas. So I have some applications. So I have an application called Acme Freight. And if I wanted to see all the things that are deployed to support that app, I can simply go to that space. And these are all the applications that support it. And if we want to take a look at that application, which I won't really be talking about much here, it's another sample application that I've developed, but it's a microservice-based application, and all of this is essentially being served by these sets of applications here. So we see that these three are running, the others are stopped because they're actually my dev stack, and these two are just some apps I was playing with. So these top three here are actually what's serving the Acme Freight application. If I wanted to kind of jump in and see how that application is running, I can do that as well. So just clicking this, for example, I can see here, I can mess with the number of instances, the memory, the allocation, and that kind of thing. Okay, so it says my application is running. Awesome. Let's just go to the dashboard and go to the dev space where I deployed it and take a look at that running application. Called it Loopback Cars Sci. Sweet. So clicking it to make sure that everything is smooth running. Let's visit the app URL. So again, like I said, you guys could go to loopback-cars-sci.mybloomix.net and actually see these APIs for yourself and even store things in my database. I should probably put some level of authentication in front of it, but for the sake of this demo, I think we're good. So again, let's do get just to make sure our cars are still in the database. Yep. And we can even do a post, or we can get a specific car. We can filter, just update a model. Fact is, there's all these APIs were automatically created for us. And all we did was create the model to actually kick off that process. I think Loopback is a really cool tool for just getting started with creating CRUD endpoints. I think in the long run, it's one of those things that has so much flexibility and extensibility that although it seems like a great kind of toy to play with, it's one of those things where if you really wanted to, you can launch VS Code, you can jump into the code itself and write custom connectors and boot scripts and really route how API calls are handled. It's one of those things that might seem simple at start, but is extremely extensible and can grow to support even the most complex database and CRUD use cases. Let's maybe quickly talk about a use case for why you might want to use Loopback. And I was introducing Acme Freight to you, and I think this might be a good example for me to kind of use to explain how you would want to use Loopback. So scrolling down here, let's take a look at the architecture for this application, right? So we've got the user on the left side who accesses the front-end application, which in turn accesses the back-end to that front-end. That front-end is calling some APIs provided by an API gateway, which is in turn calling our Loopback service. In this particular example, Loopback is being used to store all of the information about distribution centers, shipments, as well as retail locations. So the front-end application, anytime that it wants to retrieve all of the shipments to show live on the screen, what it'll do is actually it'll go and access the Loopback application that serves those actual shipments and distribution centers and that kind of thing, all of the data layer. And we can see here that in a list view, you can kind of see how it starts to look more like a database, right? And just to kind of prove to you that this application is using Loopback in the backend, let's jump back to our IBM Cloud dashboard. We'll go to the Acme Freight space. We'll go to the ERP application, which is that Loopback app that I was talking about. And let's see if we can access it directly. I may have set some security policies to prevent it, but I'm pretty sure this is my development version, and I expect it to allow me to actually access the app directly. Yep, here we go. And here we go. So this is a more complex example, definitely. But what it does is it allows you to create users, manage distribution centers, users again, products, retailers, shipments, as well as suppliers. So this is an example of Loopback that really takes advantage of all of the capabilities. And you can see that for a company that might want to create a logistics solution, much like the one that we have here, Loopback is the perfect microservice layer for handling database access and control. And as we can see here in the architecture diagram, once again, in this fictional situation, that Loopback app is providing access to a backend database that may be on-prem, maybe it's a SaaS application, maybe it's in a different cloud. But the fact is, using Loopback and a secure gateway, we're able to access that secure data and expose those endpoints for the Acme Freight application to actually go in there and either retrieve data or store data. I think that if you want to learn more about this sample or just Loopback in general, I highly recommend simply going to Loopback.io. Thought I had it open here somewhere. Okay, going to Loopback.io, checking out some of the docs and examples. There's a lot of folks out there that have created really cool samples. In fact, I think one of my coworkers, David Akun, has created a video, set up a Loopback in 5 minutes. So he's created a great video where within 5 minutes, you can get started with creating your own Loopback instance. So definitely check this video out if you want to get started with developing with Loopback. And finally, if you want to use, if you want to see this supply chain management application in action, check out Acme Freight. So again, it's totally open source, all on GitHub. You can play with this application, the Loopback layer, everything. The link should be working. Here we go. So it's just github.com/IBM/Acme-Freight. Check it out, guys. Lots of cool technology here where we actually dive into using API gateways, API Connect, and it really just pushes the kind of boundary on all of the things that are possible when you bring together multiple solutions on IBM Cloud. But yeah, I want to thank everyone for your time. I hope you found this useful. I'm definitely very passionate about Loopback. I think it's a very cool piece of technology. If you want to reach out to me, ask me questions directly. My Twitter is @Cy_Vennam. I'll pull it up right here. Definitely reach out, follow, send me a message. I should be pretty good about getting back to you. But again, thanks so much for your time, everyone.
All right. Welcome back, folks. My name's Sean Dague. I'm a developer advocate within IBM and focusing on cloud containers, open source things. Today, I thought it would be kind of interesting and fun. I know folks are working on their Call for Code projects to jump over to the front end side of the world and do a little walkthrough of building out a React application on the front. I've been doing this over the last month as part of an effort here, and which is just the right time to have gotten enough of this in my head to still be able to explain to other people that are learning it, because there's a bunch to jump into. So we'll just get rolling, and Mike's joining me here to keep me honest and ask me questions along the way. Mike, you want to introduce yourself as well? Great. Cool. So So to get started, the best thing to do is to install. There's now a tool called Create React App. That you can go find on npm. This is what you're looking for, and this is going to give you a basic boilerplate of what's going on. So we will do that to get us up and running. Great. We can now create a React app and give it some name. Doesn't really matter. And this is going to build us out a basic initial framework for this application. You know, including pulling all the dependencies you need and setting up a directory structure. So let's see what we've got in here. Well, let's actually just start with getting it running. So away we go. Hey, we have an application, and this application is, you know, got sort of some fancy CSS animations here, and says to get started, go edit this file. So let's see what it actually provided for us. Oops. So if we navigate down into this directory structure, down in source, we've got, it says go edit this app.js file. And what we're looking at here is something looks a little different if you're used to touching JavaScript in other contexts. It's called JSX, which has a mix of doing JavaScript like ES 2016, kind of modern JavaScript, but it also has inline markup itself, inline HTML markup. Is what you're actually building is you're building these components that you can then use later as kind of their own markup elements, and we'll walk through doing some of that. So the way the environment's set up, this is all running and monitoring for changes to files. So if we just, you know, start actually editing here, it's going to immediately change what we're seeing on screen. And so that's great. It's, you know, very responsive to, hey, I'm going to go make some changes, and away we go. We've got the changes available right there. It is worth understanding a little bit about how all the React pieces are glued together, because it's a whole bunch of libraries that and this boilerplate is setting you up this basic index.html file. And down in here, there's a div with a root element, because that's the hook for all of React to work off of. This is the script that's loaded by default. And what it's doing is it's making a specific call which says, go find that root element and replace it with this piece of markup, which looks like it's kind of HTML, but is not, you know, standard HTML markup. It's a SAP markup. That is this app.js file we just looked at, that we've created a new piece of markup here. So let's make another one and see kind of how this works. We'll just call this like hello. And we'll also give it this default render method, which is what it's going to return at the end of the day. One of the few tricks is that you can't, class is a reserved word in JavaScript. So anytime you would type class in markup, you have to type class name and it translates it as it goes. That's totally fair. So, okay, so we're going to say, you know, hello there. Okay, that's all that is going to do. it reloaded in the background. We made a widget. We haven't used it yet. So let's use it. Now it's a widget. We can use it just like HTML. And there it is. So that's cool. So that means that as we start building a more complicated application, the model with React is that you basically kind of wireframe out what you're trying to do in your application. And then every time you kind of find yourself drawing a little smaller box, you're like, oh, well, this is really like a widget. So I will make that another component. But right now, all these components are completely static, right? That's like not super interesting. So now we get into there's sort of two sets of things inside a component that that you'd modify or use to pass data back and forth. And there's properties and state. We'll start with properties. So properties are by default, you get a properties object, JavaScript object, passed down into these components. And so I'm going to give me a second to grab a little bit of code that does this. So we can do something here where we want to say hello to someone in particular. And the way we would send these properties down is like this. So now I can take data from a higher order component and I can pass it into other components through these properties. And these are relatively static, so that's good. But it's a good way to, if I want to put all my logic of computing some things in the top level component and I want to send it down, this is a great way to do it. You can also send like functions down as properties. And so you can see how your lowest level properties might just be like things that just, or your lowest level components might just be things that just have this render method and you pass them properties and they kind of fill out like little templates. So that's pretty cool. There's the other piece that's pretty interesting about this, or the other piece that's important, is state, because there's a sort of a question, right? So I made a change to this code, and because we're in a development environment, we're monitoring changes for that code, and so the entire screen re-renders. That's fine, right? But that's not the way like a real application works. So if we did something like, let's create something that would be like a login form. And I can extend a component again. This time, I'm going to want a constructor. And I'm going to want to spell it right to make life simpler. Because what I'm going to do is actually define part of the state attribute for the JavaScript component. So by default, in order to get all the properties work that we want to get done, we got to like pass up the superclass. But then we can do something like this dot state equals, we're going to care about two things. Username and password. Okay. And it's super helpful when you spell things correctly. Okay, cool. So we've got this. Now we'll have like a more complicated rendering environment. I'm going to grab a little. Ooh, I'm going to see if this cut and paste is going to work the way I think it is. Totally did work. Cool. And render, I need a return statement. So this has got a few more things in it. That's fine. And then we will throw a, and I called that a login form, so we'll throw a login form in here. Right, so now we've got a login form in our page, and it's got some fields. Okay, so what are these fields? We've got inputs, and we are going to define an on-change handler here about when something changes in here, we're going to do something with that. So what might we want to actually do with that? If we want to handle our username change, the way that you typically handle these when you're dealing with React is you kind of, for form, as the user's typing in it, you're going to take that information, you're going to put it into these state objects. And then these state objects are local to this component. And then at some point later, we're going to click the submit button, and then we would do something with that. We would maybe send it somewhere, or we might send it to another component. So I'm going to do a pretty basic thing here where we're going to do sure, yeah, for sure. So set state is one of these things that's provided for with React. So this gives us a way to kind of set the state of what's happening here. So I'll do a really basic thing here where we are setting the username to this is the event that's been sent in. If you're familiar with JavaScript, like the old JavaScript event model, like this would have all the modifiers of like what happened. It's a keystroke, did it have modifiers on it? Was it a mouse click or whatnot? And for good measure, so we can see what's going on, let's actually see what this looks like. So after we handle this event, or while we're handling this event, let's like look at the state. Okay, so we'll bring up our Chrome inspector here. And we'll say Mike. Now, curiously enough, like as I type, what you're seeing is the last time this happened, right? Everything's asynchronous. This is not necessarily happening in the order that it's the setting of the state ends up happening after we do the console print, and that's just the nature of asynchronous events. So we wouldn't want to obviously like do anything with this data right here, right now, because it would be not sort of as consistent final state. But okay, so we're gonna do, set the state here. We're gonna have to do the same thing with passwords. We're setting a different part of the state. And then we'd want to do something when we submit this. So for right now, because we're not going to like, in this very minimal example, we're not going to wire this straight to a backend service yet, because we're going to add some more complexity before we get there. But what you can do, we'll do the same thing we're doing before, we'll print out the state, and let's see how that all works. So, right, we've got, some random user, some random password in here that has been picked up from a different bit of testing. And when I hit the login button, I can actually see that the user and password were printed out, the state was printed out. But something else happened when I hit the login button, if you were paying attention, right? This whole page refreshed. Because login and forms in HTML have a semantic already. They have a semantic that when you hit a submit button on a login form, it sends that to some URL, some service. So if we're doing kind of proper single page apps, which is what React's really good for, building these like feature-rich, very interactive applications that don't do page refreshes like this. We only re-render the portion of the page we want. We got to prevent that from happening. And so there's a way to do that, which is that you call this prevent default function, which is, you know what? I know that on a submit, you think you're supposed to post to a page somewhere else. And in this case, that page was ourselves. But you know what? Don't do that anymore. And so now we've prevented that from happening. So we've got the interaction that we would want where we would do this login, we would do some sort of call to a REST service, and then take the results from there. So this is much of what React is right here. It is this combination of understanding that there's property and state. State impacts when things are re-rendered, and that there's this inline markup mechanism that means that you can get yourself components. What's really happening when you build this is that it's being pretty well optimized for what part of the page needs to be re-rendered. So if a change to state happens within the login form, it will only change the login form portion of the rendering. And this is done through something called a shadow DOM, and won't get into the details of that too much. But there are some pretty neat tools for working with React, with these React developer tools, that you can get as a Chrome or Firefox extension that will let you kind of see the React view of the markup world, right? We've got this app, this root app, and then we've got some markup in there, and then we have a couple of these other kind of interesting widgets in here. And we can see things about the internals of these widgets. So like what properties they've got and what state they have, which can be very useful in understanding what's actually going on. So this gives us kind of our lightweight, this is what the markup sort of looks like, and then here's the internals, the important internals of property and state. So with that under our belt, like, okay, this is great. But how would you actually start gluing this together into a more real application that's actually talking on the wire and doing a complicated set of things? So one way you can do that is that you can start writing additional methods, like in this app class, that you can kind of think of this top level app class as the thing that's going to drive mostly your logic for your environment. So you could write some methods in here and you could pass them down to the various widgets. The thing that you might find yourself doing is that you end up passing, we'd have something where it's like, oh, hey, I'm going to pass like the login form. If I actually want the application to control it, I would have to pass it like a login function, which I would pass here, and then I would pass it maybe what I'm supposed to do after login, and some other things that you would have to pass down, and you'd be spending a lot of time passing kind of methods from top level bits down. And so there's a general pattern that has grown up in the React community called Flux, which is to have a global state store of some version. And there's a bunch of open source implementations of this as well. So the thing I'm going to dive into now is we're going to jump forward a little bit and look at the internals of a slightly more robust application with some more things embedded in it. And to get a sense of like how much more is embedded in it, you know, package.json for a simple React app is like, hey, we've got React and we've got a few additional helper libraries that we need to make this happen. So we're looking at this sample kind of modernized healthcare system using some API Connect backend stuff, similar to what Sai just showed us. And you will see that within the front end portion of this code, we have a few more dependencies. And we'll talk a little bit about what these are, and then we'll kind of start up this application and see what's going on, and especially see what's happening with some of these tools. So, so Axios is a JavaScript library that's used for making REST web service calls. It's like really nice, uses promises. The important things that we'll really look into is some of these Redux portions, because these are a way of building this global state store that we're basically going to connect a bunch of methods to, and we're going to send some data back and forth. So in order to get that started, we will stop this. We're going to kick up a backend. Run our server. And that's good. Oh, that's not good. I'm going to source some API keys. All this code is going to be is part of something we're working on that will be coming out shortly. Go back to remember all my screen hotkeys. Okay. Okay. All right. So this environment, we've got like a login screen. So that's pretty neat. When we hit the login screen, it's going to take us to something which looks like kind of a patient dashboard. These are all made up users and data that exists there. So how do we get here? Well, if we look into this environment, we can see this has same basic app top level component, right? And what is it's doing is we've added, we've got call outs to other things like this info bar. There's an error panel in the event that we got an error off the server. We have a sort of consolidated way of handling that. And then we've got some stuff around routes here, and we'll explain the routes in a little bit. But each of these end up effectively rendering another component. So like the patient dashboard is what we're looking at here. Okay, great. What makes up a patient dashboard? Well, kind of two things. One of which is there's a whole list of patients, and these are again like another component that we can render. And then there's some stuff around appointments and recommended actions, and these are just placeholder widgets, and that we will put content into later. But there's a few other things that happen. So let's actually look through the login mechanism, which I have here, because this, hey, looks a lot like what we were just building before, right? We've got a constructor that's calling out super, and it has a basic state of username and password. So I'm gonna log back out, and we're gonna walk through what happens, how we would connect this up with this other infrastructure. Right, so we've got our username and password changes. We've got a login method. And then we have this. This is where things start to get a little different. Because the real question was like, what are you going to do after you've collected your states for username and passwords? You've made it so it doesn't submit to the wrong place. But what are you going to do with that method? And then how are you going to get the information back and move your entire application through, a bigger set of states? And Redux, one of the things it provides you with is this dispatch mechanism. And this dispatch mechanism is going to send you into this world of actions. And I'm going to find here we go. Here's our action. The client here is the Axios basic web service client. So we can make any kind of HTTP call we want, gets, posts, whatever. So we make a call to our root service. We call it auth. We send username and password to it. And then if we got an access token back, we're going to store this in local session, but we're going to do this kind of interesting thing here, which is we're dispatching to another method, which is this login user succeeded. This looks a little funky first time through, but login user succeeded is sending a message type, because this is the way the Redux system works. And we can see this. It's basically, it has a global state that starts at Redux. Play forward. See if I can actually get my. No, I'm having. Oh, I don't want my log monitor. I want my inspector. The global state store, we can see what it looks like at any given time. And what I found in working through the React environment is pretty quickly, after you get like about 6 widgets, passing things just between each of them is kind of too complicated to keep it all in your head. But what I have in this environment is this global state store that kind of keeps track of just a few things, right? Like, who's the user? The user is a big object. It's going to include all that patient information, whatever. We're going to keep around a JavaScript web token. This will let us make additional calls as our authenticated user. And we're going to have a few other things that we can keep track of. And every bit of these functions is basically like, hey, I'm going to send a state and I'm going to change some piece of this. I'm going to send a message like our user succeeded, our login succeeded. And if that's the case, like, then I'm going to set the JavaScript web token. And that's it. And I'm going to leave the rest of my state. This is, fun new JavaScript syntax for take the existing state variable that exists and use all of its defaults, and then we can override things that we want to change. So at every point, what we're actually doing is modifying this global state and saying like, hey, I can move my user, change my user has become this complex object. And as we navigate through the system, we can see what our states are at every time. And there's this really great bit, again, of like developer debug tools with Redux that will let us inspect as we go the entire state tree and what changes in each of these things. And that might be because we went to a new page. So we're going to keep track of the path. It might be because we're going to make a call out to some other services and find something like locations of nearby flu shot clinics. And this is all accomplished by just, putting things into the main state, right? When we log out, what have we done when we logged out? We nullified the JavaScript web token. We nullified the user. So this feels like a lot to kind of get your head wrapped around. But what I actually discovered is the code becomes a lot simpler as soon as you move into this Redux model with React, because everything, it's like, hey, I want to do something new. Okay, I build something that in this reducers setup that changes the global state, and then I export a couple of functions in actions, like what happens when logout happens, which is down here. We just say that we pull things out of the token. We do a user succeeded message, and then, or the logout succeeded message, and then we send the screen back to the login screen. So yeah, so it's kind of fun. Yes, and the really exciting thing on a debug front too, and what makes, I think, the Redux portion so interesting is that states are managed as this global chain of states. You aren't like ever modifying the old state. You're just tacking a new one on there, which is why we get this entire tree, which also means that we can go back in time and say, like, oh, well, what happened when we were here? And when something goes wrong and it doesn't look right, you can actually kind of go back and say, well, like, did we go off the rails here? Can I go look inside the states and figure out like what I'm missing, or what, maybe the relationship between these things got messed up in a way that I did not expect. And so that's an extremely useful portion of the debugging. And you can do things like where's my state inject? That's fair. So one of the things I found, part of it too is about what is the experience you want to present to your users, right? And I definitely come from the state of the world where I've written a lot of web applications like Ruby on Rails stuff, PHP, extensions of Drupal, WordPress, and have definitely found, you get into that traditional model of like, hey, well, we take a page refresh and we might use JavaScript in a progressive way to enhance our experience. So that's cool. But it does mean that there's some minimum amount of time where when you click on some operation, it takes some amount of time to actually change the world. And I think I messed everything up by jumping way. So there's some minimum amount of time it takes to do just a navigation from one page to another, right? That experience, as we live in a more app-centric world, is one that people are less interested in having, right? They want to have something that feels like the whole application is native and local, even when it's on the web. And so with React, what you end up doing is you move a bunch of this logic into the front end side. All the rendering is now bundled in the front end side. That's going to happen. And when appropriate, you you make calls back to the server to do things. So we can see sometimes we can see it. I don't know that I've got every oh, we can see it on the network, right? Network version of this is a good way to look at it, right? So you know, once I've logged in, you know, this isn't making a network call. This is data I've already got, and I can do a re-render of the page based on that. If I'm going to go out and find out about flu shots, this actually ends up being a web service call, which takes a certain amount of time. Is apparently taking more time this time. Sweet. Let's reload. I have a feeling that my state jumping made life less good. So, you know, what happened here is that we end up actually making two different backend calls. One is a geocoding call. So we call our Python intermediary web service with this store search, and that ends up making a geocoding call to Mapbox, and then using its latitude and longitude that it found for like a reasonably close address, makes a call to Walgreens, has an API that you can search for like services, including flu shots. So, you know, two API calls are being made in the back end using global API keys. You're allowed to make them because we know who you are and do that from our Python middleware. And then, you know, make a call and give you some results, which are totally goofy results because this person's address is listed as Toronto, and turns out the Walgreens API only works for US cities. So these are the closest US cities to Toronto, should you want to know that. I think we've got a few more of these have slightly more useful data. Yeah. Well, we are, and there's a big reason for that, right? Which is that the web, the thing that's awesome about the web is there are billions and billions of web pages. You're never going to translate that experience into native code. But you know, processors and web browsers have gotten much faster, much better. A lot of what this is doing with its shadow DOM makes it render quite fast. So yeah, in 2006, we weren't there yet. We didn't have the browsers and we didn't have the processors to give us what felt like, you know, a quick experience on these, you know, on one of these. But that's changed. And more importantly, you know, if you look at the current statistics and trends, the number of apps that people are willing to install on their phone keeps going down, right? People just aren't in the app craze anymore. So what you want to think about is an experience which works great, both in a full, you know, desktop web browser as well as mobile. And this is all using Bootstrap. So like, if we do something like, yay, from a phone perspective, oh, I guess I could just do the web tools just as well, right? Right, this is what it looks like on an iPhone, and has the same kind of experience that one might expect. You know, a little bit of delay here because we have to make a web service call, and that could always be more optimized as you go. And obviously, I need to like tweak this rendering because this is the ugliest, newest piece of rendering in there. But it's, you know, reasonably good stuff. I don't know. You know, any other thoughts, Mike, about? So I won't call myself necessarily an expert in all these things at this point, but it has been a great learning journey. And like one thing I want to point out to folks is there's actually, if you're interested, this book I found is one of the better ones out there, which actually walks you through both the React and Redux side of the world in gory detail, and demonstrating what you would need to make pretty complicated environments. React itself by itself is cool. It gives you some very quick rendering for like if you don't have more than a couple of pages of an app, but the complexity requires that you have a global state store pretty quickly. Otherwise, you find yourself spending all this time like passing data between components, which is not fun. All right, well, okay. Great, thank you, Mike. Enjoy all.
All right. Cool. Hey, everybody. I think this is my first time on Twitch and on the IBM Code channel. So quick introduction, I suppose. My name is Kevin Hoyt, and I'm a program manager here at IBM. I lead a team of developer advocates focused on what we call emerging technologies, which changes all the time as technology does. People on my team focus on things like serverless, blockchain. We even have some language stuff, Java, Node.js. And of course, as emerging technology goes, it kind of branches off into other areas too, right? So, if you write an app in Java EE or Node.js and you want to run it somewhere, you probably need you might want to get into Docker or Kubernetes or things like that. So we kind of splash over there a little bit. Or on the flip side, if you want to do anything with machine learning, we have a whole other team focused on machine learning. We have a whole other team focused on like containers and infrastructure, but sometimes we'll splash over there. So we kind of get around. My personal interests for the better part of the past year have really been focused on computer vision. And the reason I came across computer vision as an interest is multifold. But let me kind of frame this in the landscape of call for code. So if you look at this picture, which is an aerial picture, probably, I don't know who took it, I don't know where it comes from specifically. We're going to say that it's a drone with a camera on the bottom right, something along those lines. And it's flying over a disaster area, or an area that's been affected by, in this case, it's like a hurricane or some immense flooding, right? When it looks down on this, and it takes this picture, there's a lot going on in this picture. Right, there's probably, I don't know, a dozen or so houses. There's probably another dozen or so trees, another dozen or so cars. We could see in these areas there's blue there, there's blue here. Those are probably pools. And so as humans, we look at this, we see this image, and we can quickly discern all those details. The computer isn't quite step up to that. So so that's where my interest in computer vision kind of emerged. Let me give you an example here. I'm going to take this image. I'm going to just jump over here to a little kind of test harness that I have for Watson visual recognition, and I'm going to put this image into Watson visual recognition, and we'll see what it comes back with.
This looks like a floodlight.
A floodlight. A floodlight? I mean, a flood maybe, but a floodlight? Like, that's kind of an odd thing to see. And that's because there's so much information in the picture. Again, for you and I as humans, we can easily discern fence lines and houses and cars. We can see that some of the cars are different colors. Looks like there's a couple pickup trucks here. That's easy for us to see, but when you throw a whole image like this coming off of a video feed or as individual snapshots to machine learning, it kind of freaks out. It doesn't really know what to do with all that data. And to really kind of start needing to narrowing it down, and just to kind of make sure that this isn't just a Watson thing. This happens with any other kind of machine model that you might have. For example, one of the kind of core machine learning image models is called ImageNet. So here I have TensorFlow with the ImageNet model strapped into it. And when I put that picture into TensorFlow,
This looks like an altar.
looks like an altar. Okay, great. So it's not exclusive necessarily to Watson. Again, the problem is there's so much information coming at the machine learning algorithms that it just doesn't know what to do with it. And so that's kind of, when you think about that problem, how do you break it down? Well, you break it down by isolating and figuring out what parts of the image are actually pertinent that you want to run machine learning on. So for example, rather than taking a whole picture, we might find out that there are houses here, isolate the image containing the individual house, and then send that individual house up to the machine learning algorithm to see maybe if there's any people on the roof. Or maybe there's people, oftentimes in disasters will write messages on the roofs of who's in the house and that they need help or things like that. So maybe you want to do some text extraction, or maybe you want to track that specific area for changes over time, or even changes within and that could be changes over like a great period of time. It could be changes within within a video feed, so second by second. And again, being able to track that is going to be something that you're going to have to break each individual kind of part and piece that you're interested in down to understand better. And so the techniques for doing that have actually been around for a long time. Falls into a category that generally falls under this kind of AI umbrella called computer vision. So when we think about computer vision, I think a lot of people think, oh, machine learning, computer vision, right? Like we're just like here. Yeah, that's computer vision against a trained model, and the limitations of that model are going to represent limitations in what you can see in it, as we've seen. When I talk about computer vision, in this case, I'm actually talking about extracting the geography, the topology, the details from the image and breaking it down in a means that allows us to really focus, if you will, on the geometry of the picture rather than the pixels of the picture, and to do that kind of in a more discrete and focused manner. So these computer vision techniques are immensely powerful. When you look at something like a self-driving vehicle, when it's looking out, of course, it has numerous sensors from infrared and thermal and LiDAR and things like that. They're giving input, but also the cameras. And the cameras are taking apart the image and looking for things that are moving in certain directions and looking for things that might be humans and so on and so forth. That's traditional computer vision. And that happens even inside of an autopilot type feature with, for example, like a Tesla or something like that. So when you get into this world of computer vision, though, you will find, while the concepts aren't that hard to get your head around, the problem is the vocabulary. There's a very different vocabulary. Just like as you get into, for example, if you've experienced machine learning, right off you get into this idea of models. So there's models, and then there's convolutional neural networks. If you're getting into like TensorFlow, the core of TensorFlow is the tensor. What is a tensor? And then the different kind of vocabulary used to put the different models, the different learning phases together. Right, there's this whole kind of new vocabulary that comes into being that you kind of need to get yourself familiar with. So that's what I want to do here over the next few, say 30 minutes or so with computer vision for you. I want to give you kind of an introduction as to the different computer vision terms you might encounter, so that if you want to go out and use a library like OpenCV, or there are a lot of other kind of piecemeal ones that are kind of less robust to get at the individual pieces of data inside the image, so that you can process those further with a machine learning algorithm. That's what I want to kind of familiarize you with. So let's go ahead and do that. Oh, so I should also mention the other reason that I kind of got into this realm. So looking at images and extracting information from drone imagery is one of those reasons that I became fascinated with computer vision. The other reason is actually this guy. This is a Rubik's Cube, right? So traditionally considered a kid's puzzle, but it's one of my favorite things to do. as I'm just kind of fidgeting around, hanging around. And it actually makes a great platform for teaching STEM. So, right, you've got like arrays and matrices and vectors and all kinds of different things you can kind of teach from this puzzle. But it also makes a great platform for demonstrating how to do computer vision because we have lots of kind of geometric shapes and colors and things like that that we might choose to track onto in terms of tracking or extracting or what have you. So I'm gonna kind of walk you through this in the context of a Rubik's Cube, although it certainly could be, once you're familiarized with these terms, you can certainly apply the terms to a disaster image such as we've demonstrated here. What I'll do is as I go through some of these steps, I'll kind of make parallels as well. All right. So we're going to get kind of meta here. I'm going to be in the camera and in the browser and in the Twitch stream inception. All right. So what we're going to do is talk about the first thing that computer vision wants to accomplish. And almost always the first thing that computer vision wants to accomplish is this: grayscale. So you might think that's odd to reach to the first thing you want to do to see what's in an image is to remove the color. The reason for that is because color is noise. To us, color blocks in our human vision can help us figure out where things are in space. But to a computer, especially within the context of computer vision, as it's kind of scanning through the pixels and trying to extrapolate the geometry of the scene, going from what is us to be one shade of brown to another shade of brown, if they're close enough, our eyes don't even really discern the difference. We would just call that brown. But the computer, it's going to see, but depending on how the light hits it or what color the light is itself, it's going to actually have subtle variations. And so as computer vision algorithms start to try to take apart that image, it's going to see it's going to hit different pixels that we would want it to ignore, that it will otherwise see as different changes, and accept that as a change and use that to further enhance the geometry of the image. We don't want that. We want to be able to kind of think about it as a broad plane. So the first thing we do is extrapolate the color, pull off the color by making a grayscale. So grayscale is one of those things you'll hear a lot as a first step. If you go into OpenCV, for example, look at some of the examples in OpenCV, which is kind of the de facto standard. It's huge, robust beast, but it's available on tons of platforms and a great technology to work with. But it's huge. It's huge. And you may not need all of that. So there are other alternatives to look at. But if you are looking at OpenCV examples, one of the things you'll see almost always in terms of computer vision is grayscale. It's like the very first line of almost all these examples. So once we've got grayscale, we've removed the color, made it easier for the computer to go and extrapolate the geometry. Now, once we do that, the next actual step is to do this. This is a Gaussian blur. Now, there's lots of different ways to actually blur, and if you get into the vernacular, you'll find that there are lots of different ways, different names for this kind of stuff for blurring. You can actually blur linearly, you can blur vertically, you can do all kinds of different blurs. The Gaussian blur is a special blur that is often used in computer vision to get, again, further kind of smooth out the delta in the image. So before, when, for example, on the wall behind me here, as we're scanning this kind of section of the wall, this is just drywall with some tape and stuff on it. But right, we even with grayscale, we might have come across and find certain variations as we're scanning the pixels to form the geometry. Now that we've smoothed it out, it actually just looks more like a single color, and that's going to make it easier for us to extrapolate the geometry. So grayscale is one of those things you're going to see. Blurring of some fashion, usually Gaussian, is the other thing you're going to see. Now, also to know about Gaussian is it usually takes a kernel as a measure of how far to blur things. Just think of that as a simple two-dimensional array with how many pixels around that central point as it goes across to that you want it to blur, just how far you want it to blur. So that kind of term kernel means there in this case. So, so now that we've kind of dimmed out the image, the next thing that you'll often run across is being able to detect where the edges are in that image. So this mode is called a canny edge detector. And canny edge detector is one of the more common edge detection algorithms. Again, you'll see it used quite frequently. And what it's doing is it's crawling across the pixels, and it's looking for a variation, a certain variation that you specify as part of the call to the algorithm. So, for example, let's say we're looking for at least a 10 pixel, a threshold of 10. Let's just call it a threshold for now, a threshold of 10. So as it's going across the image, looking at each of these pixels, it says, hey, is pixel 3 any different from pixel 2? And when it does that, if it's outside of the threshold, we say, yeah, this is way different. So this might be a line. So let's call that point a line. And then it goes on and says, is 4 any different from 3? Is 5 any different from 4? And so on and so forth. So what it's happening here is it's scrolling those pixels, looking at the variations. When it finds a variation, it turns that specific pixel into white. And if it doesn't find a variation, it turns that into black. And so effectively, one of the term you'll hear here is a binary image. So turn it to a binary image. So we've gone away from full color to binary image. And that may seem really odd, but it's really but it surfaces the lines. And that's kind of, like, if you think about we're trying to extrapolate the geometry, that makes a lot of sense. Now let me put the cube back in line here, and you can see the cube stands out clear as day. If I wanted to figure out where in this image the cube was, that is very clear thanks to those lines, right? Now it's very clear to us. It's not a whole bunch clearer yet to the computer. We're going to work on refining that. But you can see here now, because we grayscaled it, because we Gaussian blurred it, because we've now used a canny edge detector to figure out where the variations are, extracting something like this is going to be much easier. And if we go back to our original kind of disaster image, right? If you're grayscale this, you Gaussian it, you're going through it. The delta from a house to the water that's surrounding it is going to be significant, as well as the fences, right? And so it's going to be very easy at this point to start kind of extrapolating the geometry of just that specific area of the screen. And like I said, then we can pass that to the machine learning algorithms for further processing, so that it doesn't get overwhelmed by all the houses in the image shot. Okay. So canny edge detection, we're still working with pixels. And so our next step in terms of moving into a geometry is to move away from the pixels. We want to move from pixels into vectors effectively, right? We'll say line starts at this point and it goes to this point. Another line starts at this point and goes to this point. And by the way, these two lines are very close together, so they might actually form a specific shape, right? Those are the types of things that we're trying to get into that we can do with geometry and trigonometry, but we first have to get away from this pixel representation. So there are a few different ways to kind of go about this. One of the more common ones you'll see is called line contouring or image contouring. And so what we've done now is we've gone through in this contour mode, effectively taken all the white dots that we would otherwise represent as X and Y pixels, right? Where in the image is pixels. And we've turned it into a geometry with 0, 0 being the upper left-hand corner. Now I've turned it into a geometry. And the blue lines you see here on top of the white lines, I'll kind of keep piling layers up. The blue lines represent the actual geometry at this point. So now what I have back is effectively an array of points. And those points represent some point in the image. And that, now we've jumped from pixels to just XY geometries. I'm not worried about colors, RGBAs, or shades of gray or anything like that. And just now I've got XY geometric points. And I can do all kinds of fun stuff with geometry. So let's do one of those. So in this case, now I've moved on to what's called approximate polygon approximation, which in like OpenCV or other computer vision libraries, you'll often see approx poly or something along those lines. Usually it's polygon approximation. I don't know why we programmers like to switch things around to make it reverse, but there it is. And so what this is doing is it's taking all those X and Y points that I got from the geometry earlier and saying, hey, these ones that are close together, let's turn those into actual polygons. Let's make them shapes. And this, again, as we look at the cube, kind of starts to help break down. Now we have specific areas in the image where we see these kind of, effectively to us, we would say it's kind of squarish or square shapes, right? And that helps us. That helps us from a geometry perspective. Say, okay, we've got shapes. We want to find the squares in the cube, or the discrete polygons in our housing detection, as it were, and extrapolate those. So that's good. So a polygon approximation is definitely taking our points and giving us polygons. Now with polygons, it's up to us to kind of take the next step. You want to figure out whatever polygon scenario is right for you is the ones you want to look at. In the case of the cube, for example, I'm looking at the cube as a square, right? So I'm looking for a square. A square has geometric principles, right? There are 4 sides. They are roughly equivalent in length, right? In terms of a true square, from a geometry perspective, they'd be exactly equivalent. But because of camera distortion, or maybe I've tilted this a little bit, they're not going to be necessarily the same. So what we'll do is we'll say, give me within, if the sides are, within in number of pixels the same distance, or in number of units the same distance, we usually, right? The distance between 2 points is a geometric trigonometric function. So we say if this distance and this distance is too far apart, then we can do things. We could say that here's our line. If this line is roughly parallel to this line, then do these things. If they're the same length, do these things. So now we can start breaking down the cube. And of course, once we have polygons, the first thing I would probably do from a cube perspective is say, are there 4 corners? Right? Because that's going to be the first thing we're going to think about of a square, or even just a rectangular shape in general. Are there 4 corners? So 4 corners, that's a great step forward. And then what I can do is say, and then once I have, so I can, all these little triangles that are getting popped up on the screen, all those go away. I get to focus on just those individual polygons of 4 points in them. And then I can start comparing their edges. I can start comparing the angles, right? You might remember Mr. Pythagorean theorem from your trig classes, right? So now I can start looking at the angles of the corners and see if they're within a threshold of 90 degrees, because that's what I'm looking at for a rectangle. So I can already start digging down into those. And so when I apply my own kind of logic for that, you can actually see the squares that are being detected pop out pretty clearly. And so we've gone, just to kind of revisit, we've gone from grayscale to Gaussian. We've done a canny edge detection. We've moved that using contours to a geometric representation. And then we have approximated the polygons. Once we've got the polygons, we iterate through the polygons and figure out which ones match the criteria we are interested in finding. And in this case, then, when I'm looking for squares, this is what we're getting. So you might, now there are a lot of squares in the square, and in the house there might be lots of different shapes that come out as polygons with 4 points on them. And so maybe you want to look for inner or outer, right? And you can do that too, right? You have with trig and geometry at your disposal. You can say, do these squares overlap? Is one inside the other? Is one way off to the edge? I can ignore those. I can ignore other aspects of them. Maybe they're kind of really close to one another. Maybe I have 2 squares that are pretty much right on top of each other, just for whatever reason. The shadows, for example, might give you polygons that are pretty much right on top of each other, but just shifted a little bit. So if they're really close together, then we can eliminate one of them. Maybe we want them to be a certain percentage of the image, right? So if I'm looking for rectangles for the houses here, that might be different from looking at the rectangles for the fence lines, or rectangles of other things that might show up in the image itself. So I could say, is it a specific portion of the image, right? So is this area, right? So calculating the area, so width times height of the polygon I've detected, and width times height of the entire image, right? Is there a certain ratio there that fits? So so once we start doing that, we can really kind of extrapolate more information. And so in this case, what I've done now is I've said, based on where those inner squares are, what I'm really interested in is where the total bounds of where those squares are represented by. And that shows up as a green kind of square here. So now all I've really done at this point is just some more math effectively to figure it out. From there, if we remove all the noise, what surfaces and what you probably would want to paint in the end of the day for someone analyzing the images or for extrapolating the images is just the original image itself. So now we can see where the cube is clearly. The computer's finding it. I have a certain ratio that I expect it to be effectively horizontal. So it's looking for that as well when I tilt it too far. But again, that's just math that I've chosen to use for my specific model. And so then from here, what I might do is say, okay, there's where the bounds are. So let's take that portion of the image, send that off to machine learning and see what it sees. And that would be a way to extract all those houses out of there and see maybe if there are people on top of those houses, or if there are words on top of those houses and things like that. All right. So that gives you an idea. Some of the other terms you might hear, I'm going to give you just a few more before we move on to other areas of computer vision. And one is called Huff transform. So what a Huff transform does is it crawls through the pixels, and as it goes through each of the individual pixels, it actually shoots a tangent off, and how many degrees at for each tangent of that pixel you want to shoot off is up to you, usually in a Huff transform. And what it will do is then shoot off a tangent, and it'll look across that tangent and say, hey, I found 6 white pixels along the way. If I found 6 white pixels, is that a line? Is that enough to constitute a line? How far is the distance between those pixels? Maybe that makes a difference, right? So a Huff transform allows you to account for that. And that's what we're actually seeing here is the lines where it's drawing these, it's figuring out these tangents, and there's some heavy lines represented. If I put the cube in there, it'll kind of surface really, really dramatically as well. And so with a Huff transform, we can start to kind of extrapolate, hey, look, these lines are showing up roughly in the same place all the time. This is probably maybe where our bounds are for what we're looking for. So a Huff transform is a great way to do that. I know you look at these lines and they shoot all the way across the screen. That's a traditional Huff transform looks for the entire duration of the image pixels it's sent. There's another way to go about it. Say, this is probably a line. That's called a probabilistic Huff transform. And in this case, it's actually trying to keep it discrete to a specific area. So if I put the cube in there now, we get a much more concise view of it. And so then you can use those lines to, again, further extrapolate the details. Other things that come up. So let's do this. So one of the libraries I like to use in JavaScript is called JSFeet. The reason I don't generally tend to use OpenCV in a lot of my work is because it is so heavy. Right, at least in JavaScript, the optimized version weighs in at like 6, 7, 8 meg, I think is what it is. So that's a really beefy library. Now maybe if you're talking about disaster recovery and a dedicated app for that, maybe that's fine, right? Over a dial-up, which might be a situation in a disaster, you might want to have smaller libraries that can be cached with service workers or things like that. Or for whatever language you're using, you might find other ways to optimize. So JSFeet is one of the libraries I like to use. But specifically what I want to show you here is called a Lucas-Kanad optical flow. So a Lucas-Kanad optical flow. There's more vocab for you, right? This is more about the vocab and how to look at these libraries and understand how to use them, and then apply them for your own purposes in terms of call for code or disaster recovery or whatever it is you're trying to achieve. And so if we take the cube in here, what it's waiting for is for me to specify some points. So if I've extracted that, this is the space I'm looking for, and I want to track that space as maybe the drone moves over it or whatever the case may be, Lucas-Kanad says, hey, specify for me some points to look at within the context of the image, and then I will try to find, what I'll do is I'll sample the kind of pixels around those points, and I'll try to find those points no matter where in the image. And so I'm going to specify this inner black space here. Right? I'm going to click here. 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 So now I'm tracking the inner space. I've given the Lucas-Canard algorithm these 4 pixels, and now as I move this around, you see it tracks it, and it doesn't care much about tilt or anything else because it's again tracking that individual segment. So Lucas-Canard is a great way to say, hey, I think I found something. Let's track it and extrapolate the image from that, pass that to machine learning, or do some other alerts or notifications you might want to do. So that's a Lucas-Canard algorithm. So now we can extract geometry now. We can track geometry. Let's get a little bit deeper into what we might do once we've extracted that set of geometry. Let's do this. So if I'm looking at an image of a disaster from a drone, I may not see faces. Maybe from a boat, I'll see faces. Maybe I want to do some sort of facial detection on the imagery. So that's what's going on here. You can see my beard actually gets kind of chopped off. Don't look as cool without the beard, but no, anyway, so this is doing facial detection. Now, key things to keep in mind here: facial detection is different from facial alignment, which is different from facial recognition. Okay, so there's different vocab terms to keep in point. Here, I'm literally just detecting where a face is in the image. Now, how does this happen? As you get into the vocabulary of how this happens, some of the terms you'll run across here are Viola Jones, which is the algorithm that is used for pattern matching in this case. And the other one you'll hear is eigenfaces, which is a collection of faces. And so what's happened is researchers have taken a bunch of faces and extrapolated kind of core patterns from that. And you can kind of think about it like this. Right? If you look at my face up here, there's this kind of open space, and then as I come down my face, there's these 2 darker areas that maybe form a rectangle like so, and then there's another pixel here or so, another block that's centered and darker, and then we come down here and there's this other space called my mouth that's another kind of long aspect. So what researchers have done have figured out what those kind of patterns are, and they're represented in what's called eigenfaces, and then you can run those patterns. Not in a machine model way, not like we're actually literally like having the neural net look at the different pixel representations, but in terms of just matching that pattern. If you distill this image down of the face all the way down to, let's say 8 by 8 pixels, like really tiny, then the eigenfaces will still match. They're just really looking for a numerical representation. So we get way down in there, we're looking for those pattern matches. The Viola Jones is a pattern matching technique that is used frequently for facial detection. The other one you'll hear around facial detection is called a Haar cascade. It's H-A-A-R. A Haar cascade is another way that faces are detected within the context of an image. And it's done, again, through pattern matching of what the structure of a face effectively looks like. Now, so if you're driving by in a boat in a flood zone, right, and you have a camera on board, you can start now detecting the faces of the people and extrapolating those faces, and maybe then you can run them through facial recognition or do other processing on them. Other things you might want to do is something like facial alignment. So this is a little tricky in this case with my beard and the way I'm kind of sitting back. If I pull this up a little bit, it's a little better. So in this case, you can actually see facial alignment is giving me the features of my face. And maybe this helps identify the person. Maybe it helps to determine their distress levels, right? Certain distress levels might, I need help. And the mouth is going to be a different shape. The eyes will be open. So this is a technique you can use, again, within the context of computer vision to determine the situation of what's going on. All right, let me put this back down. By the way, this is also how like those facial emojis are. You want to put a beard on somebody if you want to have some fun. This is how something like that works. So then facial recognition is a whole other tier. I'm not going to get into that. I will though talk about just mention also head tracking. So Two of the other terms you'll hear in terms of computer vision are scale invariance and rotation invariance. And what this effectively means is that it doesn't scale invariance means that it doesn't matter if I'm looking for the pattern in an image, it's 2,000 pixels across or 300 pixels across. If I've taken that same image and shrunk it all the way down, it will still find the exact same thing in that picture. That's scale invariance. So it doesn't matter. Take the same picture and scale it all kinds of different ways, even distort it. In a lot of these algorithms cases, it won't matter. You'll still be able to extract the same features from any of those different sets if you're using a scale invariant algorithm. The other one is rotation invariant, and in that case, right, you can't assume that everybody's going to be standing up and looking at the boat, for example, in a flood scenario. So, they might be laying down on the roof, in which case their head's going to be tilted. And so what you want to do is you want to extrapolate that and then tilt it or do other processing. But you want to be able to find out that you still want to be able to find that there is a face there, even though it's tilted. And that's rotation invariance. Doesn't matter how the object is tilted, we can still access and extrapolate those bits and pieces. So that's scale and then rotation invariance, in this case, applied to facial detection. Now, that's faces. Like as I mentioned, with a drone, we might be kind of rolling over a roof, a series of houses, right, a neighborhood, and you might see text on the top of the roof, SOS, and things like that. So this is what once we've got the house extracted, we can send that off and say, hey, what text is in there? Now it turns out Watson actually doesn't do optical character recognition, doesn't have that feature, but there are libraries that do. So one of those libraries that I like to use and that has lots of different platform support is called Tesseract. And let me show you a couple of variations here. Actually, so let me show you extracting text. So if we take something like, so I recently gave this talk at a conference called the Heartland Developers Conference.
Heartland Developers Conference.
So in this case, what I've done is run a brute force glyph detection for object recognition. So glyphs are the characters, right? So brute force that. It extrapolates just the glyphs, it kind of finds and matches up. And here in the dev tools, we can see it comes up with Heartland Developers Conference. That's kind of a brute force like textual extraction. And that may be useful for some cases. It's certainly very fast. One of the problems that can come up here is that it's not very smart. It's really this in this case is designed for like scanned text, so it's limited in that respect. If I put a more robust image in there, something like a picture of a sign on a road, it's really going to struggle with that. Even if I find the geometry of the sign, extract just the sign and pass that on, it's still going to struggle. Just a brute force glyph detection is going to struggle with extracting all the information properly. And then you might also have things like language problems. Signs might be in English and Spanish, for example, especially here in the US or other languages in other parts of the world, right? So if you're going to do glyph detection, you need to have libraries for each of those various languages. And this is why I like to lean on Tesseract. So Tesseract, again, has lots of different platforms that support it on. And it actually surfaces a machine learning network, a convolutional network in the process of OCR. And this actually gives us a lot more information about what it is that we are looking at. So in this case, let's now what you're looking at is a test harness for Tesseract. And if I put the text in there again, so now we see that not only is it extracting the words, it's actually finding the baseline, the bounding boxes for the words, the baseline for the words, and this will work really well even if it's like the way I do this in the workshop at my conferences that I present this at. I have it printed on a piece of paper, and you can tilt the piece of paper and it will find the words. So once you can kind of it'll find the bounding boxes regardless of whether or not they're horizontal or rotated. So it's rotation invariant. One of the other cool things about using a machine learning model is you're going to get a lot of extra information. So for example, here we're getting a confidence on the whole of 88. So it's pretty confident about what it knows. It sees 3 different lines. If we break down these lines, we see the bounding boxes and things like that. But then here again is the confidence. So it's pretty sure that it's 89% sure that it sees the word heartland. And it's 88% sure that it sees both the words developers and confidence. So the kind of probabilities are very helpful when you're trying to figure out what to do next. Like, how accurate is it? Because when you're doing OCR in the real world against things like signs that maybe you don't know, maybe you want to extract the name of a street sign or whatever, or like I said, the text on a roof. That's not going to necessarily be a perfect Arial font or Helvetica or whatever, right? It's going to be somebody with paint or paper or toilet paper, or they're going to somehow make that sign. So you want to be able to have some sort of probabilities to understand in your algorithm how close you are, so that you can further kind of dig down on whether or not you want to say, yes, that is a piece of text, and then what does it actually say, and send that off if it's SOS or whatever the case may be. So machine learning applied here through Tesseract is a great way to kind of start doing optical character recognition. Let's see if there's any other things that come up. I think the other thing I would talk about in terms of like a disaster, being ahead of disasters or working with disaster content in terms of call for code, will probably be one additional algorithm to talk about here. So let's do this. So this is Watson. This is my Watson test harness. And if I take the Watson and I say, hey, let's see, what is this?
This looks like a street.
Well, so for the most part, Watson's right. It's a scene of a street, right? Again, too much information. We want to extract information. And if I take this and give it to TensorFlow, what does TensorFlow using ImageNet come across as?
This looks like a limousine.
A limousine, because it thinks these cars are all strung together, right? So it thinks that's a really long car, right? Probably. So it's thinking that's a limousine, right? So again, way too much information. So we want to get at the individual parts and pieces of the information, especially in a city scene, in an urban scene. There's all kinds of geometry in here. You can extract the windows, the lines, the buildings, the street lines. There's all kinds of geometry we can extract using those techniques I've mentioned. But it turns out that sometimes, there's actually a machine learning model that's built specifically for extracting the parts and pieces out of an urban scene. It uses a technique called YOLO. So you'll often hear this referred to, the model referred to as YOLO. And that's not, you only live once, that's what it is. It actually means you only look once. And what this does is it's a really fascinating algorithm. This is actually a modern innovation when it comes to computer vision. I think the YOLO was written up in an academic paper in 2006 or something like that. So it's maybe even later, like 2011. It's a fairly recent innovation of how to process the image in an urban scene to extract the parts and pieces. And YOLO is designed to take one pass of the image effectively, which is where you get the you only look once, one pass of the image, and extract all the kind of core features. Now, it won't go so far as to tell you what those features are. It's just trying to look for core features in the image. And it does this by all kinds of interesting groupings, pixel groupings, and it says, well, what it first does is divides it off into a grid. It says, look at this grid. Is this grid, is this similar to this grid? Is it similar to this grid? So as it goes along, it builds these kind of swatches within the grid that look like they might be congruent parts and pieces. And it says, yeah, and then it says, these are the objects in the image. So now let's take this and look at running it against the YOLO algorithm here. So we'll take that street, run it into YOLO. Oh, I didn't. So there we go. So now I run it against YOLO, and we see, the individual cars have been called out in this case. It actually also sees this up here, this flag bit up here. It thinks it's a street light, which is probably not too bad of an estimation. But so this has gone through, looked at it once, pulled out all these parts and pieces, and now we can take these parts and pieces and send them off to machine learning to identify what they are. Or maybe we want to run some additional computer vision on the parts and pieces to extract just those, to extract more details. Like if we got a picture of a car, then, is there a license plate? We got a picture of a person on a bike, can we get the face, right? Those different kinds of things that might be interesting to us from a computer vision standpoint before we even process things with machine learning. So the idea behind this particular talk, again, is really leveraging computer vision to maximize your machine learning. I think one of those things we find with developers trying to use Watson for the first time is they look at it as though they've got a hammer. If you've got a hammer, everything's a nail, right? So if you just throw stuff at it, it's supposed to spit back something accurate. And they're often very kind of disappointed when it doesn't do that. And that's, again, that's because they've neglected the other parts of the AI umbrella to kind of weave this story together to most effectively extrapolate information. In this case, computer vision. So computer vision can be used to process that image heavily right up front, get the pieces, send it on to machine learning. So when machine learning gets the bits it needs, it's really going to have some valuable information for you. Whew. All right. So just a quick recap on some of the terms here, okay? Just because I know we've been through a lot of information. Not that one. All right. So the things we've looked at here. So grayscale, right? So grayscale is one of those terms, turns to gray. Gaussian blur, or smooth it. You often hear image smoothing as a term used in computer vision. Canny edge detection, or edge detection in general, to pinpoint where the edges are in the image. Dilation is actually just making things bigger and smaller. We can talk about that. Threshold is one of those, is another way to approach this. Right, this is a threshold version of contouring. And if we ran this against the contour, we can get some shapes too. This is pretty friendly in terms of the cube itself. Right, so there's lots of different ways. This is actually more performant than a canny. It takes the color image and goes straight to this dot representation. So there's thresholds, contours, polygon approximation, geometry and trigonometry. Get your books out, dust them off. Bounds detection through our own application and interpretation of what the scene should be made of that we're interested in looking at. Huff transform, looking for lines in the context of the scene. A probabilistic Huff transform is narrowing it down to say, yeah, this line starts at point A and ends at point B, rather than just being a line in general. We've talked about facial detection, facial alignment, scale invariance, rotation invariance, OCR, or optical character recognition. We've talked about machine learning, specifically in this case, actually YOLO, you only look once. And I think probably a few other things I'm missing in there. So those are the kind of vernacular that you'll want to use as you get into computer vision. And when you apply those to computer vision, you come away with a much more efficient way to leverage the machine learning capabilities of neural networks. Whew. All right, Michael, I think that does it. It's a lot of material. Thanks everybody for stopping by and listening to me ramble about computer vision.
All right, folks. Well, thank you for joining the live stream. My name is Daniel Krook. I'm a developer advocate and software engineer, and one of the IBM mentors for Call for Code. So you can find me in Slack, callforcode.slack.com. My handle is just my last name, @Krook. You can find me at Twitter. It should be on the screen right now. So if you have any issues, questions about Call for Code in general, or more in particular about submitting, which is what we'll talk about in the next few minutes, you can reach out to me. I want to make sure that you are able to submit the best quality application you can, and that you don't lose out by being disqualified by maybe forgetting a required form submission piece of information, or otherwise submitting that maybe is not going to compete against some of the best stuff that's been submitted or will be submitted so far. So so yeah, as always, we've got the live stream going this Friday. You can find me virtually. We've also got next Friday. If you go to callforcode.org right now, it'll bounce you over to our /Fridays page, our Call for Code Fridays. So since next Friday is the submission deadline, we're going to probably run a full day of office hours during the 4-hour block to make sure that you've got any questions, any configuration stuff solved, and make sure that you're entered in the competition. And you've also got this nice handy little countdown clock here that's going to stress you out for the next 7 days. It's been stressing me out. You're just looking at it for the last 90 days or so. But that'll say what it is. So it's midnight Friday Pacific time. So hopefully, if you're around the world, you're getting most of that Friday as well to do some last minute development. Okay, so I'm going to take you through a reminder of what Call for Code, the project, is looking for, so that can help you build the best quality submission you have. Again, we're not looking for hacks, things that are just thrown together. By now, ideally, you've worked through a solution and you're kind of in the home stretch now building something. But we also know that many developers do their best work under pressure. So we want to make sure we've got the broadest arrangement of things submitted to the competition. So let's take a look, just a refresher about the competition, right? So participating in Call for Code, most of you, I hope, will have already gone through these steps. If you are a team lead, you may have some other teammates that may not have completed a few other steps, but basically the first step you had was to go over to callforcode.org/challenge. You can click the register link on the top nav as well. And this will get you eligible for the competition. So there's two different concepts. There's the individual developer or participant, and then there's the team. So there's two different tools for managing that. So the first thing you do is you register, and the reason for that is that gets you access to IBM technology, gets you access to the digital communities on IBM Coder, on Slack. You accept a code of conduct there, so people abide by some standard human decency guidelines and interacting with each other in virtual communities. And it also has you accept the participation agreement so that you understand your rights around the IP of your application, how it's going to be judged, and where it may go after the competition, so that it actually gets deployed somewhere. So you've done that. You'll get an email immediately with a link to go sign up for an IBM account. You'll get unlimited free tier access for a while. You also have $200 of credits if you submit a credit card. If you provide a credit card, it won't be charged. But you will, if you start to use some of the paid services, you may bounce up to the top of that free credit. So there's a video that Tim Robinson, my colleague, created, shows you how to take the best advantage of that. So you'll get the IBM account. Then you'll also get a link to go build with the code patterns. So you may have already had an application in mind which you want to build, but there's also inspirational stuff out there, pre-built applications you can leverage in your submission. Step 4, work through finding teammates, understanding technology, looking through the resources we have in the community to engage, to help you answer questions. And then finally, which is what you'll have to do before next Friday, the end of the day next Friday, is to actually submit your solution that you've built. So that's where I'll focus on mainly on this this talk, and we're going to help folks do over the next 7 days. So again, Call for Code is looking for a way to prevent, respond to, and recover from natural disasters. And these affect people all around the world. So the applications you build that are maybe inspired by your experience locally, perhaps by dealing with a hurricane in your local community, it may be a solution that someone across the world may be able to reuse in the context of a typhoon, for example. So we're looking at a whole bunch of potential problem areas, and hopefully developers who are a growing force around the world can take their solutions and build applications that help communities prepare in advance and save lives by preventing loss to a natural disaster, to responding to them in real time, and building back afterwards. So that's the whole Call for Code goal, right? Take a very compelling problem that is stretched to the bounds of its current solutions, apply technology from a world-growing community of developers, and bring that all together through a competition that's founded by lots and lots of sponsors, affiliates, partners, and a growing community of supporters, which you can all find on callforcode.org/ecosystem. So again, why would you even submit for the competition, right? Obviously, you want to save lives, improve the health of your community, and ideally help others around the world as well. But there's a huge prize structure involved. There is an award that will be given to the one grand prize team. That will be the inaugural Call for Code Global Award, awarded on October 29th at a benefit concert in San Francisco. There's a $200,000 cash prize that will be won by that grand prize team. Either an individual submitter or a team of up to 5 can split that. The project you build, it's not just something to push over the finish line here. It is something that's going to, the winning solutions are going to be given a home in a Linux Foundation, where they'll be provided the support, IP protection, or the IP guidelines and framework that can help build communities around them, establish codes of conduct, things like that, as well as provide some marketing help around the project. You'll have the grand prize team will also have a chance to pitch to a venture capitalist firm, NEA. And so what you build here, as you create and as you bring it to the submission deadline, it could be something that you've been working on for the last couple months, but you could turn into basically your next company, your next career, as it were. And along with that is an opportunity to also take the technology, work with IBM's Corporate Service Corps, which has been around for 10 years, has deployed 1,000 different projects around the world, and work with IBM to take your idea, take the solution you built, and put it into play where it's needed most. The second and third prize winners will also have a cash award and opportunity with the Linux Foundation. So those are also compelling. So if you're not the top prize, there's definitely awards that are in there for you. And because we want to see the best solutions and we want those applied around the world for the long term, we want to make sure that even if you don't make it to these top 5 tiers, that there's a structure and encouragement to still continue to develop it as an open source project. Okay, so the number one part of creating a good solution is making sure that you're identifying the right solution scope, right? So we want to build applications that solve problems identified by experts in the field, be it the United Nations, Red Cross, individual local authorities. And we want solutions that are going to safeguard communities, protect them from natural disasters, help them recover from, and just save lives through technology. Find the best way to do that. So there's a couple of frameworks you can look at. I'll get to these a little bit later, but the Sendai framework defines some targets. There's a lot of potential solution areas that you can find in there, as well as some information from the Red Cross as well on collaborating between public and private. Okay, looking at the overall schedule, the biggest one here is the September 28th submission deadline, next Friday. I'll get into what's actually submitted on that form a little later here. But you're going to go through, after you submit, your application will be assigned to a large team of developers who will go through it, make sure that it's technically complete, that's feasible, that solves a problem. And we're also bringing in NGO partners and affiliate partners from universities, for example. So you're going to have your application is going to be looked at by a set of judges that not only are experts in the IBM cloud technologies, but they're also experts in whether this technology is actually going to solve a real world problem. And there's also several different types of judges that will filter through, check it for scalability, transferability, all the judging criteria, until finally it gets to the final round, where eminent technologists like Linus Torvalds, the inventor of Linux and Git, will choose the finalist, choose the ultimate winner, along with a few of our experts from the field, from Columbia University, for example. There's also Grace Kim from Twitter. You can find all of the judges that will be in the final tier on callforcode.org/challenge. there's also a menu item under ecosystem for eminent judges. But it will go through several rounds and will be thoroughly tested, and they will select the final winner from what's made it to that final round. And the top 3 teams will be invited to the award event on October 29th. So there will be a benefit concert there for the UN Human Rights Office as well as the American Red Cross. Okay, so you've decided you've built something that actually solves a real world problem. You're ready to kind of double check your work against what the judges are going to be looking at, and it's pretty straightforward in terms of the judging criteria. So there's a 20-point scale. It's broken out into 4 areas of 5 points, and there are key areas that kind of touch on the functional requirements that you've achieved, the functional impact you've made, as well as some of the non-functional aspects of how well it performs, how speedy it is, how easy it is to work with, as well as your target audience, whether that's somebody who's doing some long-term planning at a computer, whether that's someone in the field using a mobile application or controlling a drone. We'll look at how your application is able to be taken from, well, how complete it is. Can it be built, transferred? Can it be set up by somebody? Can it be easily understood? Does it solve a real world problem? That's the effectiveness and efficiency. Is it usable? And then finally, does it take a new approach to perhaps a long-standing problem? Does it have an immediate 10 times better approach to solving a particular problem, either by just doing something very clever or even just radically simplifying how a process gets done, such as paying out claims, ensuring that fraud is not in the system. So we're looking at lots of different ways that you can apply the technology in an effective way to make a difference. As you registered and as you submit as well, just make sure you go back to that participation agreement that you downloaded when you registered. You can also find it under the FAQ section on callforcode.org. Take a look at that. Make sure that everybody who's on your team of up to 5 people has registered, understands that they're over 18, all the conditions of the competition. Remember that as a team lead, you can be a team of 1, a team of up to 5. There will be only 1 person from the team submitting them. So not all 5 team members, for example, need to submit. It's just the 1 team member. You'll list the emails of the folks that are on your team and who have registered. And make sure you're using something from the IBM cloud. We've provided a whole bunch of cloud, AI, data, blockchain, as well as standard virtual machines, platforms as a service runtimes, PHP, Node.js, Java, you name it. There's a whole slew of services to take advantage of, so please do that, as well as any sort of open source projects that you want to integrate. And you can integrate data sources from across the internet. You can integrate with, for example, Google Maps as a plotting library for some of your data. So use the IBM cloud, but you can use data sources from everywhere, open source, and what are the services are available to you. And if you haven't already, just take a look at, maybe you started from scratch when you were thinking about your application, but there's a whole bunch of code patterns you can still choose to build upon. And each of these code patterns, these technology areas, has a team lead that's assigned to them. So these people are available within the IBM Coder community, within Slack, and they're able to help you make best use of the technology. So if something's not clear, for example, how you deploy a WordPress application to the IBM cloud, maybe use the web dashboard, ping an IBM mentor in Slack or one of these particular areas if it's related to one of the technologies that you're interested in using. Everybody's happy to help, and we want to make sure that that you're spending time building an application that matters and not struggling with any technology where there might be a straightforward solution to how to use it. We're here to make it easier for you. Okay, so assuming you've built out that application, you understand the solution that you want to build. Just like the judging criteria, the actual application form or the submission form that you'll fill out is pretty straightforward. There's only 8 questions on it. And what you'll do is you'll find a link to Unoodle within Slack. It's also in that 5-step chart I shared earlier. You'll create an account on unoodle.com. Again, only the team lead needs to do this, not the entire team. And what you'll do is you'll fill out the team name. Don't put your own name in there, just put a team name that's kind of easy to remember. The judges will, for the most part, anonymously look at what you submitted. They won't look at teammate names and emails. They'll just see a team name. So provide the team name, provide up to 4 of your other colleagues who are collaborating with you on this. You don't have to include your own email address here. You can, but just keep in mind that it's already tracked as the person who created the Unoodle account. And make sure that that's actually a working email address. We've been running an internal competition, and we've seen a couple folks listed where clearly there was a typo in the email address, and we had to find out what their real address was. Just be aware, simple stuff like that can mean the difference between if the judge even sees your application that you worked on for so hard, for so long. So be aware of that. You'll give a high-level pitch. This is just a 7-word or less description of what you've built, why it matters. You'll then create about a page worth of documentation, describes the problem, why it's important, ideally providing some statistics or a story in there. Talk about your solution at a high level, and discuss basically the sort of impact that this is going to have. Right? The end goal is to save lives through technology. A preparedness application can save, a magnitude more lives in advance than maybe a recovery solution. Just try to frame the scope of what you're solving here for the judges to understand. You can upload a solution roadmap. This is pretty free form. Depends on the application that you're building. If you're building a mobile application versus an analytics application, kind of the way you describe it, the way you talk about how mature it is, how it should be deployed. That could be a Word document, a PDF, a PowerPoint. It can be anything that makes sense for you. There's no prescriptive format for that. You'll provide a link to GitHub or another source code repository. I'll get to some best practices about that pretty soon. But obviously, the crux of what you're submitting is not an idea. It is functional working code that can solve a problem. It's a great question. That one has come up before. So normally what you do there is, like many open source projects, is you provide a README, you provide a list of steps, and you would tell the judges, for example, if they have to create an instance of Watson Studio, you tell someone to go create their own instance of it. The judge who's doing the deep dive will go create their own instance and get their own service credentials. In some other cases, there may be some issues with credentials that, if you do have any that you need to supply, if maybe, for example, there's only one instance of a particular service, it's already been configured totally the way you want it to, this form field, you can overload this, right? So you can provide the URL, and then you can follow that up with any sort of credentials you need. This is a secure form. You can provide them here. I would not put them in the repo. And there is another alternative kind of to do this. I'll get to this a bit. You can invite an outside collaborator. We've got a call for code judges ID on GitHub, and you can keep it a private repo, and they will see it that way. But the preferred way to do it is should be a public repo if possible. Give instructions for someone how they can build this application, what they need to do, maybe to populate it with data, and give it a way to be transferred from your own instance to somewhere else. But if you need to provide credentials, this is kind of your hook to do that. Or if you can't fit it in here, you can put it in other parts of the solution description area. Okay. All right, and make sure you've got once you've got the application up there, just double check the judging criteria to make sure you've covered anything, made it clear how this application addresses those criteria and the kind of impact it has. A link to a video pitch. So ideally, again, this is a public URL, but if you do have credentials for it, you can leave those in the field or somewhere else in this form where the judges can find them. And list the IBM Cloud service. You only need to use one something on the IBM Cloud. So call out how it's here, so you kind of understand how the technology is being used and kind of the amazing stuff that's being built with it. We're interested in seeing that. So once you do that, you'll save this form and you'll submit it through the Unidal system, and that will enter it in the competition. The important thing to know is that you can't go back and edit this after you submit it. So if you need to iterate on it, work with some colleagues and maybe on pulling together some information, you can save it as a draft. You can work it through. You'll spend some time on it. Just don't submit it until you're absolutely ready to. You can obviously, if you have once you provide your GitHub repo in here, obviously if there's security issues that come up or there's some changes that happen to the code itself, the core of the code, maybe to adapt to how services have changed over time, you can change things independently over in GitHub. But this form itself, your actual entry here, the list of your teammates' names, that doesn't change after submission. So again, be very sure of what you do here. Okay, so once it's submitted, you should get an email confirmation that you've submitted it, and it will go through the judging rounds, and we'll alert folks who make it to the top counts. You'll know where you stand after judging is complete, and you'll get contacted if you've made it to a certain tier. There's some travel arrangements that need to be made, some visas that need to be secured. We'll contact you through the Unidal address that you provided. So again, make sure that is correct. It's an email address that you check often. It's something that you can monitor very easily. We don't want you to lose out on the competition based on technicalities like that. Okay, so that was the form. Let me talk through a few of the tips. The other tips, I talked to some of them already, but and you may have seen some information from Brian from AngelHack earlier today. If you hadn't, it's recorded in this live stream. It was the kickoff talk. But basically, I can't stress this part enough. I mean, there's a lot of really amazing technology out there that's fun to play with. It's really cool to build something, hack together something in the afternoon. But the fundamental thing you've got to look at is this technology that's making a difference? Is it easy to use? Is it going to make an impact? Think about, honestly, if you're creating an application, is it for someone who may be under a lot of stress or panicking or doesn't speak English as a native language? Is it something that's going to help them rather than frustrate them and perhaps even make things worse for them? We don't want to see issues where we use technology for the sake of technology. Maybe it's a really cool AI application, but if it requires just a lot of concentration in the heat of the moment on a mobile device, asking too many questions, requiring too much input, or just something that somebody would frankly not even want to use and just use something simpler. Just think about that. Think about your target audience. Empathize with the persona that you're trying to build your application for. Think about whether your grandmother might use this application. Think about a young person might use this. Just think about a range of conditions it might be used in, and look to the frameworks that are provided by the NGOs. So the Sendai framework, understand what the real world solution, what problems are, where they have identified goals for improving the state of disaster preparedness. Look to that. Look to the real problems, and don't always just gravitate towards, the sexy, dramatic, really cool technology solution. We want to improve the state of disaster preparedness and recovery. We don't want to overload it with technology that's just thrown at the problem without really understanding the problem. So we've got a bunch of tech talks as well up on the developer.ibm.com call for code site. We've been running series talking to local authorities like police. We've talked to scientists in the field. We've talked to people that are helping on the ground, for example, in Puerto Rico. There's a whole bunch of tech talks where you can get great insight into the types of problems that are out there and how technology might help them. What things weren't available when they were in the midst of a crisis that they would love to have in advance. There's lots of great insight there, and you can get it here. You can find it on the web, but really, empathize again with the first responders too, those authorities that are responsible for saving lives in their community, and look to that first to make sure that your application really makes sense. And there's a bunch of other great research out in the field that helps you avoid this techno-solutionism, just throwing technology from Silicon Valley at the problem without understanding the underlying, perhaps, fundamental issues that are out there that need to be solved before technology can even make the right impact. So again, my top number one tip, find the persona, empathize with them, understand what they need, and make sure that you're not getting in the way, but you're improving what they do to save lives. Tip number two, this one goes again back to some of the, once you've built out your solution. So we've learned a lot from running this internal IBM competition, which was on an earlier time frame than the external one. And what we've learned is one of the easiest ways to really understand how capable code is if the developers have taken the time not only to build something great, to include test scripts, to include screenshots, to include things, is to really lay out in the source code repo the steps for replicating, for building, for testing, for using the technology, and also understanding how it maps out to the problem that it's solving. So there's a bunch of resources that you can you rely on. Just Googling for README best practices. There's a bunch of templates you can use. You can learn about what really goes into making it very evident for someone who's going to take either an end user down the road or a judge who's just taking a look at just a lot of submissions, and they really want to see ones that stand out. This is one of the best places to really spend your time. Make sure it's very clear what your application does. It doesn't take a lot of digging to understand how it's used or how to set it up, things like that. So look for the README best practices. Some of them don't include another bit of information, which is you can embed a link to YouTube in there, to your demo video, your screenshots. Just make it as easy as possible for someone a judge to look at that and say, okay, there's something here. There's time, there's care that went into this, there's thought that went into this. And so again, with the submission form too, you've got a lot of different ways to hook the judges. This is one of the ways. So depending on, make sure it's consistent between all these avenues, because you're going to be appealing to technical judges, to experts in the field type of judges, executive type judges, and they're all going to look at maybe they prefer to look at the demo video versus diving into the code, or they'd rather look at a PowerPoint presentation or some slides. Make sure all of these are high quality, of course, but that they also tell a similar story so that your judges, regardless of their background, can understand what you've built. Okay, and kind of building on that point, right? So one of the easiest ways to hook the judge is if they only have 3 minutes, most of them are going to just go to the video and understand what you've built to get a feel for what you've created. Again, there's many judges, and they only add incrementally to the overall score. But if you have a judge that only has a few minutes to look over a lot of submissions, this is a great way to get that hook, right? And Brian, Brian from AngelHack, if you were on the call earlier with him, talked through some of the best ways to use your time in that video. So once the thing is produced, it's under 30 seconds. I'm sorry, 30 minutes, 3 minutes. The way he suggested breaking it down was use the first 45 minutes to set the stage, lay out the scope of the problem, why it's important to solve, and how you've solved it at a high level. Then kick over to showing your solution in action, what the end user persona is that is using that application, whether it's an expert, survivor, something like that. so that they can get the feel for how complex, complete, and how it really is solving the problem, right? And then use the end time to talk about any sort of results that you've already used to compare the effectiveness of your solution against that problem and where you might go next, right? So if you personalize this around hurricanes, again, if there's a way to expand out this general idea to give judges the feel for how it might be transferred elsewhere and used in different contexts beyond the one that you highlighted in the demo video. And there's no prescribed resolution or tools for building this. From my personal point of view, what I always do with my demos, any sort of code demos in general, is I use Camtasia, I record my screen going through a demo, totally focusing on the user experience, not saying a word, just going through it, very deliberately going through the menus, showing the mobile device simulator. I capture that video. I then write out a script, or I can do that first. Write that out in a Word document or something, break it down into like 30-second segments or even 10-second segments, which you can then later splice together with the video. And it's very effective because as you're doing the demo, you're not worried too much about talking through it. You're focusing on doing it correctly. You're not wasting time doing both things at the same time poorly. It lets you focus on doing the audio in one go, the demo in another go, and it lets you cut the pieces to really fit the time that you have. So I really do recommend that you spend time on that and not wasting time watching a spinner spin, right? Make use of that time and be judicious with what you cut and what you show. Okay, tip number 4. So again, one of the lessons we've learned from judging this internally is people tend to, they get excited about the application, they build the application, create the demo video, they submit it, but they haven't maybe quite taken the time to test it outside their team, whether somebody who's not logged into YouTube, for example, or not logged into GitHub can see their application, right? So that has required a lot of churn internally that we have been able to afford, fortunately, in the internal competition, but we won't have the time to afford for the external competition. So when you fill out your application form, double check, triple check the permissions on everything. The safest thing to do is to make your GitHub repo or whatever source code repo that you have on the internet just public. If there are any credentials, as I said, include those in the form that you submit with Unidal. But if you just flip your code to public and you do that the day of the submission, where if you're afraid someone's going to steal your great idea, if you do that the day of submission, that's much less likely. And the same applies to the video. I would err on the side of just making everything public. The spirit of this competition is for people to develop solutions that the world can use. So my most thorough recommendation here is just open source it, give it an Apache 2 license. That is the most popular one. It's got a lot of advantages. I'm not a lawyer, but that's the most popular one that's out there for most applications. It's what the winning solution will have to license their application as when they go into the Linux Foundation anyway. So that may be one to explore. There's a few other as well. GitHub makes it very easy to kind of understand what's implied by each of the license types, but that's totally up to you. Apache 2 is the most popular one. So, but if you do have a private repo, there's one kind of workaround for this. We have a service ID, as it were, in GitHub, and that is call for code judges. You can invite that account as an outside collaborator to your private repo, and they would have access to see what's in your repository while it's private. It's not ideal. It makes judging a little more difficult than if it was just a public repo, but that is a potential way to keep it private while sharing it with the judges. And if you provide a private repo, private video, make sure you include those, the credentials to access it. Okay, so those were my top 4 tips. Again, the most important piece you can do, make sure is all your team members have registered for the challenge, that they're eligible, that they're over 18, that they understand what participation means. Get your account. You can share resources between your teammates by inviting other folks to your account. Look at those code patterns. There's a whole bunch of new stuff that's even to this moment being released. So for example, we even just published a blog recently with International Space Station data that comes from NASA. So you may want to look at that. There's some other patterns that have been released on a regular cadence. There's some interesting ones, some labs that have been done around drone, IoT, visual recognition. So there's still stuff that you can add to your application or swap in if you weren't happy with your current implementation. See what's out there, and always continue to watch those, the developer.ibm.com site for additional content that might help you make a stronger submission. You're going to want to rely on the community. You know, if you need any help with your submission, any recommendations, any questions, all the IBM mentors are in the Slack community, as well as monitoring the IBM Coder forums. And then go ahead and submit your solution. So here's the link, bit.ly cfc-submit. You can also find that linked from within the communities. And with that, good luck. And let me see if there's any other questions from Mike. Oh, wonderful. Fantastic. Thank you, Omar. Cool. Okay, great. Thanks. Bye.